Hello there, and welcome to Science for Sleep, where curiosity gets cozy and science takes its time. Tonight, before you drift away into the calm rhythm of thought and rest, I'd like to invite you somewhere vast. Not far away, not even beyond reach, but up. Just above the quiet ceiling of your room, past the clouds and through the thinning blue of the atmosphere, there's a darkness waiting. It isn't empty. It isn't cold in the way we sometimes imagine. It's filled with light so old and faint that your eyes could never catch it unaided. Yet it's there, silently crossing unimaginable distances, weaving stories across the night. Every speck of it, every grain of brightness you see when you look at the sky, has travelled across time and space to find you. And in that gentle light lies the question we'll explore together tonight. How many galaxies are in our universe? It's a question that sounds simple, almost playful, the sort of thing you might ask a teacher in passing or whisper to yourself while lying under the stars. But it's also one of the most profound questions a mind can hold. Because to even ask it is to acknowledge the scale of everything, to admit softly that we're very small and very curious. Galaxies aren't just faraway decorations in space. They're the homes of stars, worlds, and perhaps the dreams of other beings wondering the same thing somewhere far away. The count of galaxies isn't just a number, it's a way of measuring existence itself. If you're listening now, maybe you're lying in bed, the lights are low, and your day has finally quieted down. Maybe you've just brushed your teeth, checked your phone one last time, and are letting your thoughts drift into that calm zone between wakefulness and sleep. Maybe you've glanced out your window at a faint star or even the smear of the Milky Way, if you're lucky enough to see it where you live. Whatever your little corner of the world looks like right now, I wonder, have you ever looked up and really tried to count? Not the stars, which would already take you far longer than a lifetime, but the galaxies those stars belong to. Each one a collection of hundreds of billions of suns, each with its own planets, dust, and stories. Can we even begin to number them? And if we could, what would that number mean to us? If you find this kind of wondering soothing, if science helps you slow your breathing and curiosity helps your mind settle, I'd be grateful if you gave this video a like, maybe even subscribed. It helps this little space of calm travel out into the algorithmic universe to find others who could use a quiet moment of cosmic awe before they rest. And now, with the screens dimming and your thoughts opening up, let's wander together into the deep. You don't have to move. You don't even have to stay awake. Just listen and let the scale of things unfold at its own pace. The story begins with a simple act, looking up. It's something humans have done for as long as we've existed. Long before there were telescopes or theories or even words for the stars, people lay on their backs and stared at the night sky. They saw patterns, creatures, gods, and ancestors. They made stories out of light. The stars weren't just distant fires. They were markers of time, directions for travel, and the backdrop for imagination. But for thousands of years, even the most curious minds believed that all of those points of light belonged to one grand structure, our galaxy, the Milky Way. Everything, it seemed, was contained in that shining band stretching across the sky. The rest was just darkness. When we look at that same sky today, it's easy to forget how long it took for anyone to realize that the Milky Way was just one among many. To see beyond it required not only better instruments, but a different kind of sight, a willingness to imagine something vaster than the human mind was built to hold. We used to think our galaxy was the entire universe. Now we think the universe may hold hundreds of billions, maybe even trillions, of galaxies. And yet the journey from one belief to the other was slow, gentle and human, much like the passing of a quiet evening. It began with questions whispered into the dark, the same kind of questions that still echo when we lie awake and wonder what's out there. You might imagine that the universe, as we know it today, was mapped out by confident scientists in lab coats, but the truth is softer. It began with dreamers, poets, and astronomers who sat in the cold, peering through simple lenses and scribbling notes by lantern light. They looked at faint smudges of light through early telescopes, little cloudy patches that refused to resolve into single stars. They called them nebulae, meaning clouds. Some were indeed clouds of gas within our own galaxy, but others were something entirely different, something that would one day redefine our sense of scale. They were other galaxies, entire islands of stars so distant that their light had been travelling for millions of years to reach us. It's strange to think that when you look at the night sky, you're seeing not just space, but time. Every photon that reaches your eye is a traveller from the past. The light from the moon left it just over a second ago. The light from the nearest star took 4 years, and the light from some of the galaxies we can now see began its journey billions of years before humans existed. When we count galaxies, we're not counting what's out there now, but what was out there long ago. The universe is so vast that looking into space is the same as looking backward through time. Every galaxy is a kind of fossil of light, carrying a memory of the universe as it once was. The question, how many galaxies are there, isn't one that can be answered simply by looking harder or building bigger telescopes. It's an unfolding story, a conversation between light and mind. We used to think there were just a few thousand. Then, as telescopes improved, that number jumped to millions. Now, with the help of space telescopes orbiting above Earth's haze, the estimate has climbed into the hundreds of billions, maybe more. And yet, even that might be only the beginning. The deeper we look, the more we find. The more sensitive our instruments become, the more faint smudges appear at the edge of detection. It's as if the universe is playing a slow, gentle game of hide and seek, revealing itself one layer at a time. When astronomers talk about counting galaxies, they're really talking about sampling. They take a small patch of sky, sometimes no larger than the size of a grain of sand held at arm's length, and they examine it in exquisite detail. What they find there, they multiply across the entire sky. The results are staggering. That tiny patch might hold thousands of galaxies, each containing billions of stars. And there are thousands upon thousands of such patches in the full sphere of the sky. Even conservative estimates suggest that there are at least 2 trillion galaxies in the observable universe. But even the phrase observable universe hides a secret. We can only see as far as light has had time to travel since the universe began, about 13.8 billion years. Beyond that lies a region we can't see yet, perhaps filled with galaxies that remain forever out of reach. What's extraordinary is that every one of those galaxies, every swirl of stars and dust and dark matter, is its own cosmos. Some are giant spirals like our Milky Way, turning slowly with graceful arms. Others are elliptical, smooth, old, and filled with ancient stars. And many are small and irregular, chaotic collections of gas and light like the sparks from a cosmic fire. Between them stretch immense voids, regions so empty they make space itself feel heavy with silence. Counting galaxies is like trying to count waves on an endless sea while floating in the dark. You can measure the pattern, estimate the rhythm, but the total always slips beyond certainty. It's comforting, in a strange way, to know that even the brightest minds don't have a final number. The universe resists completion. It keeps some of its mysteries intact, as if to remind us that curiosity has no finish line. And maybe that's why the question feels so soothing to think about as night falls. There's something deeply relaxing about realizing that you don't have to know everything. You can simply wonder. The act of wondering itself connects you to the very process that built those galaxies. The unfolding of matter into stars, of stars into planets, of atoms into awareness. You, listening to this, are part of that same universe trying to count itself. Every thought you have about the galaxies is made from stardust that once burned in their cores. The air around you right now, the calcium in your bones, the iron in your blood, the oxygen in your lungs, all came from stars that lived and died billions of years ago in galaxies that might still be drifting somewhere in the dark. So when you think about the number of galaxies, remember that it's not something separate from you. You're inside one, you're made of one. The distance between you and the farthest galaxy might be unthinkable, but the material connection is intimate. The light from those galaxies passes through you, and the atoms within you once glowed with that same light. If you could somehow travel far enough, fast enough, and look back toward our own Milky Way, you would see it as just one among countless others, a glowing spiral adrift in the black ocean of space. It would be hard to tell which one was ours. Nothing about it would announce, "Here is where you came from." It would look like any other. And maybe that's the quiet lesson galaxies give us, that specialness doesn't depend on rarity. We can be one among billions and still be extraordinary. We can be tiny and still meaningful. Astronomers sometimes talk about cosmic humility. It's the feeling that comes when you realize how vast everything is, how ancient and how patient. But humility doesn't mean insignificance. In a way, it's the opposite. To see the universe as it truly is and still find beauty in it, still feel connected to it, is a form of awe that's deeply human. It's the same awe that led us to build telescopes, to launch satellites, to ask questions we can't fully answer. Counting galaxies isn't about reaching a total. It's about reaching an understanding that we belong to something greater than ourselves, and that the more we learn, the more wonder remains. If you're still awake, your breathing is probably slowed by now. Maybe your eyes are closing just a little, the edges of your thoughts beginning to blur. That's all right. You don't have to hold on to every detail. The galaxies will still be there, quietly existing whether you're awake or dreaming. Somewhere, light is still travelling, still crossing the void, still bringing faint echoes of distant stars to every corner of the cosmos. And here you are, on a small planet in a small solar system, inside a grand spiral galaxy that's one of hundreds of billions, all of it unfolding in silence, in darkness, in time. The question, how many, may never have a final answer. But that's part of the beauty. The universe isn't a finished book we can close. It's a story still being written in light, chapter after chapter, expansion after expansion. The galaxies are its sentences, the stars its words, and we are the brief conscious punctuation, a pause in the infinite noticing it all. So as you rest, imagine the faint light of those countless galaxies spreading across the dark, not to overwhelm you, but to cradle you in perspective. You're not apart from the cosmos. You are within it, of it, and it's quietly counting you too among its endless wonders. When the day fades and the air begins to cool, there's a quiet change in the way the world feels. The sounds of activity soften. The glow of human life replaces the sun for a little while, and then, one by one, the lights go out. The night doesn't arrive all at once. It slides in, slow and patient. And when it does, something remarkable happens. The ceiling above us, which looked blank during the day, becomes a window. The night sky has always been there, but it takes the absence of sunlight for us to notice it. It's strange, isn't it? How something so enormous can remain hidden until we stop looking at everything else. If you've ever found yourself standing outside on a clear night, away from the hum of the city, you'll know that particular feeling of smallness that comes when you look up and realise the stars are countless. At first, it's just a scatter of dots, uneven and delicate. Then, as your eyes adjust, the faint band of the Milky Way starts to appear, a misty ribbon stretching across the darkness, made of stars too distant to see individually. What looks like fog is actually a multitude of suns, each one a blazing sphere of fire millions of times farther than the furthest airplane you've ever watched drift across the sky. For most of human history, that band was the boundary of everything we knew. It was our entire cosmic home, and it seemed enough. Every culture has named it differently. In some old stories, it was the road of spirits, guiding the souls of the departed. Others called it spilled milk from the gods, a celestial river, or a trail of fireflies across the heavens. It's fascinating that people, separated by oceans and centuries, looked at the same faint light and saw meaning in it. Before telescopes, the Milky Way was the largest visible clue that the universe might be more complex than it appeared. Even without instruments, humans sensed that something vast was happening beyond the reach of their hands. That instinct, to look up and wonder, is perhaps our oldest science. The night sky is never quite still. It looks calm, frozen, eternal. But everything up there is in motion. The Earth spins, the Moon drifts, planets glide along their orbits, and stars themselves move through space, circling the centre of our galaxy like dancers in an unimaginably slow waltz. The patterns we call constellations are temporary alignments, illusions created by our point of view. Thousands of years from now, those same stars will have shifted into new arrangements, and the familiar shapes, the hunter, the bear, the swan, will be gone. The night sky we know is a snapshot of a moment, even if that moment lasts longer than any human life. Most people today rarely see the full sky anymore. Streetlights, car headlights, screens and buildings wash away the darkness. It's called light pollution, but that phrase hardly captures what's lost. Without darkness, the stars disappear, and with them, a sense of scale. The universe becomes theoretical, something we read about, not something we experience. But if you ever travel somewhere remote, where the air is dry and the night is deep, you'll see a sight that can make you forget to breathe. The Milky Way shines bright enough to cast a faint shadow. You can see subtle colours, the faint golden tone near the centre, the hints of blue and silver around the edges. You might even glimpse small smudges of light near it. The neighbouring galaxies called the Magellanic Clouds. When you see them for the first time, it's impossible not to feel a small shiver of recognition. Those smudges are other galaxies visible to your naked eye, other islands of stars floating beside our own. And that realization, once it lands, changes everything. The night above us isn't just a blanket of stars, it's a map of light stretching across the universe. Each point you see is part of a structure so vast that it makes human distances, miles, continents, even planetary orbit, feel tiny. The light from some of those stars left before our species existed. Some of it began its journey before Earth had oceans. You're catching the end of an ancient message, a wave of energy that has travelled unbroken through dust, magnetic fields, and time itself, only to fall quietly into your eyes tonight. Even the space between the stars isn't truly empty. It's filled with particles, radiation, and the faint glow of what scientists call the cosmic background, the leftover light from the universe's birth. That faint haze, invisible to human eyes but detectable with instruments, comes from the moment when the universe first cooled enough for atoms to form nearly 14 billion years ago. It means that when you look into the night, you're not just seeing across distance, you're seeing across time. The further you look, the older the light becomes. The night sky isn't a place, it's a history book, and every point of light is a page written in the language of physics. It's hard to grasp what those distances really mean. Our galaxy alone is 100,000 light-years across. That means that if you could travel at the speed of light, something no human or spacecraft can yet do, it would still take you 100,000 years to cross from one side to the other. That's a time span longer than all of recorded human history, and yet that vast structure is just one among billions. If the universe were reduced to a city, our galaxy would be a single house, one small structure in an endless sprawl of glowing neighbourhoods. Each galaxy holds its own version of the night sky, filled with its own constellations and perhaps its own observers, wondering in their own languages how many galaxies exist beyond theirs. When you think about it like that, the night above us becomes less like a ceiling and more like a vast ocean. We're standing at the shoreline, watching the waves of starlight roll in, knowing there are currents and depths we'll never fully explore. But just as sailors learn to navigate the sea by its stars, we navigate our understanding of the universe by the light of galaxies. Every photon that reaches us is a clue. The faintest ones come from the farthest places, carrying secrets about what the cosmos was like billions of years ago. By studying that light, scientists reconstruct the universe's story, how it grew from a dense, hot beginning into the vast web of galaxies we see today. Even with modern technology, there's something almost emotional about the act of stargazing. The telescopes may be complex, the data streams vast, but the feeling behind it is ancient. It's the same quiet urge that made our ancestors name the stars. In a way, astronomy is a form of remembering. Every time we look up, we reconnect with that lineage of curiosity. We might use digital sensors instead of our eyes, but the desire is unchanged. We're trying to understand where we are and what else might share this space with us. For most of history, the stars were thought to belong to one great sphere surrounding the Earth. The idea that they might be suns like ours, scattered through a vast void, took centuries to accept. And the thought that those suns might belong to other galaxies, entire systems beyond the Milky Way, was even harder to grasp. It's easy to imagine why. When you live under the same familiar sky every night, it feels complete. It takes a special kind of imagination to believe that the faint smudges barely visible at the edge of vision are entire universes in their own right. But that's exactly what they are. Every faint glow is an island of creation, spinning and evolving on its own cosmic timescale. The night above us is both constant and changing. The constellations shift slowly as the Earth wobbles on its axis. Stars are born and die, though we rarely see those events within a lifetime. Some stars flare up, others fade quietly, and new ones emerge from clouds of gas and dust. The Milky Way itself is moving, pulled gently by the gravity of other galaxies nearby. Someday, far in the future, it will collide with the Andromeda Galaxy, another great spiral moving toward us at hundreds of kilometers per second. When that happens, the night sky will transform. The stars of both galaxies will mingle, creating a new shape, brighter, larger, and utterly different. But that's billions of years away. For now, the two galaxies drift closer in silence, their light crossing the void like two lighthouses glimpsing each other across a dark sea. There's a quiet comfort in knowing that the stars you see tonight are part of an ever-changing universe. You don't have to understand every detail to feel its rhythm. The galaxies, the stars, the space between them. They move in patterns too large for human time, but somehow their slow motion gives our small moments meaning. When you see a shooting star, you're watching a grain of cosmic dust burn through the air. When you see the moon, you're watching sunlight reflected off rock that's been orbiting Earth for over 4 billion years. Every glance at the sky is an encounter with the past, a reminder that we're part of a continuum much older than any civilization or species. Some nights, if the air is clear and the moon is new, you can see even the faint glow of distant clusters, regions where galaxies gather together, bound by gravity. They appear as subtle patches of light, barely visible, yet each one could hold thousands of galaxies. These are the cities of the cosmos, enormous gatherings of matter shaped by invisible dark matter halos. Between them lie cosmic voids, vast spaces almost entirely empty. The pattern of clusters and voids forms what astronomers call the cosmic web, an immense structure that spans the universe. It's hard to picture, but if you could step outside the universe and look back, you'd see galaxies arranged in long filaments and knots, like veins of light stretching through darkness. And all of that begins with what you see above you on a quiet night. When ancient travellers looked up, they used the stars as guides. The sky was their map. Today we still use it as a guide, though for different kinds of journeys. Instead of crossing oceans, we cross eras. Instead of measuring miles, we measure light years. Each observation takes us a little further in understanding, but the destination keeps receding, like a horizon that moves as you walk toward it. That's part of the wonder. The night sky doesn't just show us where we are, it reminds us that there's always more to learn. Every discovery opens a new layer of mystery. Imagine, for a moment, the first time someone realised that some of those faint fuzzy patches weren't stars at all but galaxies far beyond our own. That realisation changed the human view of existence forever. It meant that our entire galaxy, the hundreds of billions of stars we once thought were the whole universe, was just one among countless others. It meant that the night sky wasn't a dome of nearby lights, but a window into an almost infinite expanse. It meant that the universe wasn't centred on us, but that we were part of something far greater, shared by everything that exists. It's humbling, yes, but also profoundly comforting. Because it means that the darkness above isn't empty at all. It's filled with company. If you were to lie back now, close your eyes, and picture the night sky, you might see the stars as tiny points scattered across black. But in reality, what you're imagining is only a fraction of what's there. Most galaxies are invisible to the human eye. Their light is too faint, their distance too great, yet they're out there, countless beyond counting. Some are so far that their light has been stretched by the expansion of the universe into wavelengths we can't see. Others are hidden behind dust, shining in infrared instead of visible light. And as our instruments improve, we keep finding more. Galaxies so faint that even the most powerful telescopes barely register them as smudges. Each discovery pushes the boundary of the known universe a little farther outward. The night above us is not just a view, it's evidence. It tells us where we came from and what we're part of. Every photon that reaches us carries information about the state of the universe when it left its source. By decoding that light, its colour, its brightness, its spectrum, astronomers can determine the age, distance, and composition of galaxies. In a way, the sky is whispering its secrets constantly. We're just learning to listen better. The more we learn, the more we realise that the universe is not static, but alive with motion, energy, and transformation. And the night above us is its most honest expression. If you've ever watched the sky long enough, you might notice how it invites stillness. Your thoughts slow down, your breath evens out, and the noise of daily life fades. That's not just the effect of quiet surroundings. It's something deeper, a resonance between your mind and the vastness you're looking at. The human brain evolved under this very sky. Its rhythms, its cycles, the turn of night and day, all of it shaped our biology. So, when you look up and feel calm, it's not a coincidence. You're aligning, however briefly, with something ancient and fundamental. The next time you step outside at night, try this. Look at a star, any star, and remember that it's part of a galaxy filled with billions more. Remember that our own galaxy is one among hundreds of billions more beyond that. And then, without needing to solve anything or reach any conclusion, just let that awareness settle. You're not separate from what you see. You're part of the same unfolding. The atoms that make up your body are the residue of stars that once burned in those distant lights. The night above you isn't just a view of the universe, it's a mirror of your origins. When people first began to map the night sky, they thought of it as a collection of individual stars. Each one was a point of light, steady and distinct. The patterns they drew between them, the constellations, were ways to make sense of what they saw. Hunters, rivers, birds, heroes, myths. Those lines were human inventions, a way to turn chaos into story. For most of history, the universe was a canvas dotted with stars and planets, all circling Earth in slow, predictable paths. It was familiar, orderly, small enough to imagine. But as our eyes and instruments grew sharper, something began to change. The stars we thought we knew began to form larger pictures. Some gathered into clusters, groups that shone together like families. Others formed bands and smudges of light that seemed to stretch across the sky in ghostly arcs. The deeper we looked, the more we realized that stars were not scattered randomly. They were organized. They lived in structures far beyond the reach of human imagination. What we call a galaxy today didn't always have that name. For a long time, even the idea was beyond language. When early astronomers saw the faint band of light that curves across the sky, they called it the Milky Way, a name born of mythology, not science. To the ancient Greeks, it was milk spilled by the goddess Hera as she nursed an infant. To the Romans, it was the path of the gods. In China, it was a river of silver light. To the Maya, it was the backbone of the sky. None of these interpretations were wrong. They were human attempts to describe something larger than comprehension. The truth would turn out to be even stranger and far more beautiful. Every single star you see with your eyes belongs to the Milky Way. Even the brightest, even the ones that seem alone in the dark, are part of a vast spiral disk that stretches for 100,000 light years. We live inside it, near one of its quieter arms, orbiting an ordinary star we call the Sun. Our entire solar system is a small detail within a single swirl of stars. The night sky, as grand as it seems, is only a local view. We see the Milky Way from the inside, looking across its dense plain. That's why it appears as a glowing band. We're looking through the thickest part of our galactic home. When Galileo turned his telescope toward that band in 1609, he saw something that startled him. The smooth glow broke apart into countless tiny points of light. The Milky Way wasn't a mist or a cloud at all. It was a sea of stars too numerous and too distant to separate by eye. That moment was one of the first cracks in the wall of our small understanding. Suddenly, the universe expanded. What looked like fog was revealed to be depth. What seemed like simplicity became complexity. The sky was no longer a flat ceiling of light. It was a vast, layered structure. Galileo's discovery was only the beginning. Over the next few centuries, astronomers like William Herschel and his sister Caroline began to survey the stars systematically. They mapped their brightness, their colours, their positions, and tried to guess how far away they were. Herschel imagined the Milky Way as a great disk filled with suns, with the sun sitting somewhere near the centre. He wasn't quite right about our position. We're actually off to one side. But his intuition was extraordinary for his time. He understood that the stars were not scattered randomly, but arranged in a grand, flattened shape. The idea that we lived inside a galaxy had begun to take hold, even if the word for it didn't yet exist. The term galaxy comes from the Greek word galaxias, meaning milky. In a way, the name was waiting for its definition all along. Once we realized that the Milky Way was a massive collection of stars, we began to wonder whether there were others. Those faint cloudy patches in the sky, the ones we called nebulae, might be something more. Some of them, like the Orion Nebula, were indeed gas clouds within our own galaxy, places where new stars were being born. But others refused to behave like that. They had structure. Through better telescopes, they revealed spiral shapes, bright cores, and arms that seemed to curve gracefully into space. Some astronomers suspected these were star systems like our own, existing far beyond the Milky Way. Others dismissed the idea. The debate would last for centuries. To think of stars grouped into islands was a radical shift in perspective. It meant that the universe was not centered on us, nor even on our galaxy. It meant that space extended farther than we could see, and that beyond our familiar stars lay other realms of equal size and wonder. Each one would contain its own billions of suns, planets, and perhaps other beings looking up at their own night skies. The stars were no longer solitary. They were citizens of galaxies, and those galaxies in turn formed a cosmic population too vast to number easily. When you imagine a galaxy, it might be tempting to picture something like a pinwheel, elegant, symmetrical, spiralling gently in the dark. Many do look that way. The Milky Way is a barred spiral, meaning it has a central bar-shaped region of stars from which its arms extend. But not all galaxies are spirals. Some are elliptical, shaped like smooth spheres or stretched footballs, filled with older, dimmer stars. Others are irregular, chaotic, and misshapen, distorted by collisions and gravity. Each type tells a story of formation and change. Spirals are lively, still forming new stars from clouds of gas and dust. Ellipticals are ancient, having used up most of their fuel. Irregulars are like snapshots of cosmic turbulence. Together, they form the diverse family of galaxies that populate the universe. What's remarkable is that all of these enormous structures obey the same physical laws. Gravity binds their stars together, shaping their orbits and keeping them in motion. Within a galaxy, stars circle the centre much as planets orbit stars. The speeds are immense, but the distances are even greater, so the motion appears slow. Our Sun, for instance, takes about 230 million years to complete one orbit around the Milky Way's centre. That means it has circled the galaxy roughly 20 times since the Earth formed. Every sunrise you've ever seen, every civilization that has existed, every fossil in the ground has occurred during a single small fraction of that long galactic journey. Between the stars lies not emptiness, but space filled with potential. Gas clouds drift through the galactic arms, collapsing under their own gravity to form new stars and planets. Supernovae, the explosive deaths of massive stars, scatter heavy elements into space, seeding future generations of worlds. Black holes sit quietly in the hearts of galaxies, including our own, shaping the orbits of stars around them. In a galaxy, creation and destruction coexist in balance. It's an ongoing process of recycling, a cosmic ecosystem that has been running for billions of years. When we call galaxies islands of stars, it's not just a poetic image. It's an accurate description of how they behave in the sea of the universe. Between galaxies lies vast emptiness, distances so large that light itself takes millions of years to cross them. The nearest large galaxy to the Milky Way, Andromeda, is over 2.5 million light-years away. Even travelling at the speed of light, a message sent to night wouldn't arrive there until long after humanity has changed beyond recognition. And yet, despite those distances, gravity connects them. Galaxies move toward and around each other, forming groups and clusters. Our Milky Way and Andromeda are members of what we call the local group, a small cluster of about 50 galaxies bound together by their shared gravity. Beyond our cluster lie others, forming vast filaments and walls across the cosmos. The universe, when seen on the largest scales, resembles a web. Galaxies strung along invisible threads of dark matter with immense voids in between. It's humbling to realize that each of those galaxies, no matter how distant, is a place. They aren't just dots on a chart. Each one has its own history, its own rhythm, its own collection of stars and planets. Some might contain civilizations, others might be entirely quiet, filled only with light and dust. If we could travel among them, we would see endless variations, galaxies colliding, merging, spinning apart. Some are shaped like whirlpools, others like cigars, some like uneven clouds. In a few rare cases, they're connected by long bridges of gas and stars pulled by tidal forces. The universe is dynamic, never static. Galaxies are born, evolve, and eventually fade, just as living things do, though on timescales so long that to us they appear eternal. Counting them, or even estimating their total, requires patience and technology beyond what human senses can manage. But the principle is simple. Astronomers take deep images of small sections of the sky, using telescopes that can detect faint light. Each image might reveal thousands of galaxies. From there, they calculate how many such sections would cover the entire sky. The number grows quickly, hundreds of billions, maybe trillions. And because many galaxies are too faint to detect even with our best instruments, the true total might be higher still. The universe doesn't stop where our vision ends. It continues in silence beyond the reach of light that has yet to arrive. It's easy to lose yourself in these numbers. They're so large they almost stop meaning anything. But if you step back, what they really describe is abundance. The universe didn't create a few galaxies, it created an overwhelming multitude. Each one is a different experiment in structure and time. Some are ancient, their stars dim and red, remnants of the early universe. Others are young, bright and blue, filled with star-forming regions that glow like embers. Together, they form a population that reflects the universe's restless creativity. To look at them is to see time unfolding on a scale too vast to hold in memory. If you think about how galaxies form, the picture becomes even more astonishing. They begin as slight irregularities in the density of matter shortly after the Big Bang. Over billions of years, those tiny variations grew under the pull of gravity, drawing in gas and dark matter, forming the first stars. These early galaxies were small and chaotic, often merging with others to become larger. Our Milky Way too was shaped by mergers, smaller galaxies swallowed over cosmic time. Even now, faint streams of stars in the halo around us are the remnants of those ancient collisions. The galaxy you live in is a collection of histories woven together by gravity. What's also fascinating is that galaxies don't exist in isolation from the rest of the universe's story. Their light tells us about cosmic expansion, how space itself stretches over time. The further away a galaxy is, the faster it seems to be receding from us, not because it's moving through space, but because space itself is expanding between us. This discovery, made in the early 20th century, revealed that the universe isn't static. It's growing, evolving, and carrying its galaxies along for the ride. Every distant galaxy is not just a light in the dark, it's a witness to the changing fabric of reality. When you lie awake at night and picture the stars, you're seeing only the closest layer of this vast structure. The galaxies beyond them stretch in all directions, forming a three-dimensional ocean of light. If our eyes could see across all wavelengths, infrared, ultraviolet, radio and beyond, the sky would glow with the faint hum of countless galaxies overlapping, their light blending into a diffuse background. The darkness of space isn't truly dark. It's filled with the faint accumulation of distant starlight, too dim for human eyes but still there, like a quiet chorus humming at the edge of perception. Sometimes it helps to think of galaxies not as things but as processes. They are the ongoing dance of gravity, gas and time. Stars are born, live and die within them. Dust clouds collapse, planets form, radiation escapes. Over billions of years, these cycles create structure, complexity and beauty. Our galaxy is not a static object, but a living system in cosmic terms, and that's true of all the others too. When we talk about how many galaxies there are, we're not counting fixed entities, we're counting living histories, each one an ongoing narrative written in light. If you close your eyes now and imagine drifting outward from Earth, you might first pass the moon, then the planets, then the edge of our solar system where the sun's influence fades. Beyond that, you'd move through the vast reaches of interstellar space, past clouds of gas, and into the emptiness that fills the gaps between the stars. Eventually you'd begin to see the Milky Way from outside, a spiral of light turning slowly in the dark. Beyond it, other spirals and shapes would come into view, each one distinct yet somehow familiar. The further you drift, the more the universe fills your field of vision. You'd realize there is no edge, no final frontier, just more galaxies fading into the distance. Counting them would be like counting grains of sand on a beach that stretches forever. The next time you look up and see a faint patch of light that doesn't twinkle like a star, consider that it might be another galaxy. Some of them, like Andromeda, are visible even without a telescope on a clear night. What you're seeing is the combined glow of 1 trillion stars, their light blended into a single soft haze by distance. It's a direct view of another world, or rather, another universe of worlds. And somewhere in that vast collection of light, there may be someone, or something, looking back in our direction, wondering if they too are alone in their galaxy, or if the night above them holds others like theirs. And so, the story unfolds from stars to islands of stars, from single points of light to the grand structures that fill the cosmos. Each discovery builds on the last, not ending the mystery but expanding it. The stars you see tonight are part of a pattern that stretches beyond sight, beyond time, beyond easy understanding. When you look up at the night sky, every star you can see belongs to one vast structure. We call it the Milky Way, though from our position within it, we can't see it as a whole. We live inside its disk, wrapped in its light, unable to step back far enough to take in the full view. It's like trying to understand an ocean while standing on a single wave. We feel its motion, its pull, its rhythm, but the shape of it remains hidden. Yet over centuries, through careful observation and patient imagination, we've come to know our galaxy as our true cosmic home, an island of hundreds of billions of stars drifting through the dark. The Milky Way is a barred spiral galaxy, a sprawling, rotating disk of stars, gas, dust and invisible matter, about 100,000 light-years across. In the centre lies a dense region of stars, an elongated bar that feeds material toward a supermassive black hole known as Sagittarius A. This black hole is millions of times the mass of our Sun, and though it's far too distant to affect our daily lives, its presence defines the centre of our galaxy's motion. Around it, stars orbit in dizzying loops, some completing a revolution in just a few years, others taking centuries. Beyond the core, the galaxy's spiral arms extend outward like gentle ripples, filled with bright new stars, nebulae, and molecular clouds, the nurseries of future suns. Our solar system sits quietly in one of those arms, about 27,000 light-years from the galactic centre. It's a safe, unremarkable neighbourhood, far from the crowded bustle of the core, where radiation and gravitational tides make life less likely. Out here, space is calm. The Sun moves through the galaxy at nearly 500,000 miles per hour, dragging Earth and its planets along. Even at that speed, one complete orbit around the Milky Way takes over 200 million years. In the time since the dinosaurs roamed Earth, we've made only one trip around the galaxy. Every epoch of life, every rise and fall of civilizations has happened during a single moment in that vast galactic journey. If we could step outside our galaxy and look back, we'd see a grand spiral turning in silence. Two main arms, the Perseus arm and the Scutum Centaurus arm, curve outward from the central bar, wrapped with countless clusters of stars. Between them lie smaller segments, like the one we inhabit, known as the Orion Spur. The entire disk is surrounded by a faint halo of older stars and globular clusters, ancient spheres of light that orbit like satellites around the galactic plane. Beyond that halo stretches something even more mysterious: dark matter. We can't see it, we can't touch it, but its gravity shapes everything. Without it, the Milky Way wouldn't hold together. It's the unseen framework of our galaxy, making up most of its mass, silently guiding the motion of stars. When astronomers map the Milky Way, they do it without ever seeing the whole picture. We're inside it, surrounded by dust that blocks visible light. Instead, we use other kinds of light, infrared, radio waves, X-rays, to peer through the haze. The structure we know today was built piece by piece, like assembling a jigsaw puzzle from the inside. Each wavelength reveals a different layer: cold gas in radio, warm dust in infrared, hot plasma in X-ray. Together, they form a portrait of our galactic home, dynamic, layered, and full of motion. Even the darkest regions between stars are alive with faint glows of radiation and drifting particles. It's easy to think of the Milky Way as static, but it's anything but still. Stars are born and die every day. Clouds of gas collapse to form new systems, while old stars explode in supernovae, scattering heavy elements into the void. These explosions enrich the galaxy, creating the building blocks of planets, life, and everything we know. The iron in your blood, the calcium in your bones, the gold in a ring. all forged in the heart of stars that lived and died in the Milky Way long before the Sun existed. The galaxy is a recycling system, turning matter into light and back again, over and over, for billions of years. You are, in every literal sense, made of this place. Our ancestors saw the Milky Way as a luminous band stretching across the night, a river of light so bright it could cast shadows. Before electric lights, before smoke and pollution dulled the air, it was a sight that shaped myth and memory. People built stories around it not because they understood it scientifically, but because they felt its presence. It connected horizons, it hinted at infinity. Even without telescopes, they sensed that it was something beyond comprehension, a pathway through the heavens, a sign of worlds unseen. When we finally discovered what it really was, a collection of hundreds of billions of stars, the wonder only deepened. Today, with our instruments orbiting high above Earth's atmosphere, we can study the Milky Way in exquisite detail. We can trace the orbits of stars around the central black hole, map the spiral arms, measure the motion of gas clouds, and even predict future collisions. One of the most important discoveries of recent decades is that galaxies like ours often grow by merging with smaller ones. The Milky Way has devoured many of its neighbours over cosmic time, pulling them in and absorbing their stars. We can still see the remnants of those mergers, faint streams of stars stretched across the sky like threads of light. They are the ghosts of galaxies past, quietly orbiting within our own. In a few billion years, our galaxy will meet its next great companion, the Andromeda Galaxy. Right now, Andromeda lies more than 2 million light-years away, but gravity is drawing us together. The two galaxies are on a slow collision course, moving closer at about 100 kilometers per second. When they finally meet, they will pass through each other, their stars rarely colliding but their shapes distorting, their spiral arms unravelling and reforming. Over time, they will merge into a single larger galaxy, often called Milkomeda. It sounds dramatic, but for life on Earth, if any still exists, it will be a distant and beautiful sight. The night sky will fill with the light of Andromeda's stars, a glowing arc stretching across the heavens. Eventually, both galaxies will settle into a new, elliptical form, calm and radiant. But for now, the Milky Way is still whole, still quietly rotating, still nurturing its stars. When you step outside on a clear night and look toward the densest part of that glowing band, you're looking toward the galactic centre, towards Sagittarius, where the black hole and bulge reside. The light that reaches you from there is tens of thousands of years old. It began its journey before humans built cities, before languages evolved, before our species even existed in its modern form. In that sense, looking at the Milky Way is a kind of time travel. Every photon carries a history lesson, every shimmer a reminder that the universe moves at a pace we can only measure in patience. The Milky Way's mass, when counted in stars, is staggering. Roughly 200 billion suns shine within its boundaries, though estimates vary. Adding gas, dust and dark matter, and the total mass reaches over 1 trillion times that of the Sun. Its disk is about 1,000 light-years thick, filled with lanes of dust that wind through its spiral arms like smoke. These lanes are where new stars form, regions dense with hydrogen and helium, cooling and collapsing under gravity's pull. The younger stars are hot and blue, clustered in groups. The oldest are red and faint, drifting in the halo where time moves slower, where the remnants of early epochs still linger. Our galaxy also hums with invisible signals. Radio waves from pulsars, the remnants of collapsed stars, sweep through space like lighthouse beams. Gamma rays flicker from regions near black holes. Cosmic rays, high-energy particles, race through the galactic magnetic field, sometimes reaching Earth after journeys lasting thousands of years. The Milky Way isn't just a collection of stars, it's an ecosystem of energy, constantly exchanging matter and radiation with the space around it. It breathes in and out. expanding its influence while being shaped by the forces within it. One of the great modern projects in astronomy is to chart our galaxy in 3 dimensions. Using satellites like Gaia, astronomers are mapping the precise positions and motions of more than 1 billion stars. The result is a living model of the Milky Way, one that shows how it swirls, ripples and bends. The data reveals waves of motion in the disk, likely caused by ancient collisions or the pull of passing galaxies. Our galaxy isn't flat, it's warped, like a vinyl record left too long in the sun. And even as we study it in such detail, we're reminded that our perspective is still limited. We're inside it, trying to understand the forest from among its trees. Sometimes, when we imagine our galaxy, it's easy to forget how much it shapes our lives here on Earth. The rhythm of day and night, the seasons, even the chemical makeup of our planet, all of it depends on our position in this galactic system. The Milky Way provided the materials for our world, and its gravitational tides subtly influence our cosmic neighbourhood. Beyond that, it gives us a sense of belonging. To know that we have a home in the dark, a structure that nurtured our sun and made life possible, is a quiet comfort. The universe may be vast and unknowable, but within it we have a place. In the quiet hours, when the world outside your window is dark, it helps to remember that you are part of this great spiral. Every atom in your body is linked to the life and death of stars that lived billions of years ago. The faint band of light across the sky isn't distant in spirit. It's your cosmic address. You exist within it, carried along by its slow rotation, bathed in its invisible glow. Whether you're awake or asleep, it moves, spins and hums around you, indifferent yet somehow intimate. If our species endures long enough, perhaps one day we'll send probes beyond the galactic plane, far enough to turn back and capture a true portrait of the Milky Way. From that perspective, our galaxy would appear as a glowing disk, pale blue and gold, its spiral arms wrapped delicately around the centre. In one of those arms, invisible in the vastness, would be a small yellow star and a tiny blue planet, and on that planet, creatures wondering what their galaxy looks like. Until that day, we rely on imagination, models, and patience. We know its shape not from a single picture, but from countless small pieces of evidence stitched together by human minds. When we think of galaxies as distant objects, we forget that we live within one. The stars you see tonight are the Milky Way seen from inside, fragments of a greater whole. They are your neighbours, your relatives in light. The space between them is vast, but connected by gravity, by shared motion, by history. The Milky Way is not something apart from you. It's your origin and your context, your environment on the grandest scale. You are born from it, you live within it, and someday the particles that make you will return to it. So when the night feels large and lonely, look up. What you're seeing is your home, not just your planet or your solar system, but the immense radiant structure that holds them all. Its light has been shining long before us and will continue long after. It's steady, patient, and full of stories still unfolding. Every glow, every shadow, every unseen thread of gravity is part of a single, vast design. And as we drift forward in our orbit, wrapped in that spiral of stars, the Milky Way keeps turning, carrying us deeper into the quiet motion of the universe. For a very long time, humanity thought the Milky Way was everything. When people spoke of the universe, they meant this single galaxy, its stars, its faint clouds, its mysterious dark patches. The night sky was full, and for most, that fullness was enough. It contained everything visible and everything imaginable. Beyond it, so they thought, was emptiness. But curiosity, once sparked, never stays still. The same impulse that led us to chart the seas and the continents eventually turned upward, asking the same question again and again. Is this all there is? When telescopes grew powerful enough to reveal details beyond what the naked eye could see, astronomers began noticing strange shapes scattered among the stars. Some of them looked like faint smudges, diffuse clouds that glowed softly. These were called nebulae, Latin for clouds. Some were star-forming regions within our galaxy, filled with gas and dust. Others, though, were different. They had spiral structures, patterns too vast and organised to be mere clouds. But what were they? Were these spirals small formations within the Milky Way, or were they immense collections of stars far beyond its edge? The debate would divide astronomers for centuries. By the late 19th century, the question had become one of the great mysteries of science. The Milky Way was mapped in rough detail by then, its size and shape guessed from the distribution of stars. Many believed it filled the entire universe, but others suspected the faint spiral nebulae might be island universes, independent systems of stars, vast and separate. The term was poetic and unsettling. If it were true, then the universe was far larger than anyone had imagined. The Milky Way would no longer be the whole story. It would be one among countless others, just a drop in a cosmic ocean. At the time, though, it was nearly impossible to measure distances to such faint objects. The stars within our own galaxy could be studied with new techniques, by observing how their brightness changed and comparing that to known types of stars. But the nebulae were too faint, too far. They resisted categorization. Some astronomers, like Lord Rosse, used enormous telescopes to sketch their shapes. He saw spirals, bright centres, and dark lanes. He described them as spiral nebulae, suspecting they might be distant worlds of their own. Others, like Shapley and Curtis, argued over whether these were within the Milky Way or beyond it. Their famous Great Debate in 1920 was the culmination of centuries of wondering. One side claimed the Milky Way contained all that existed. The other insisted it was merely one of many galaxies in a larger universe. The truth would emerge not from speculation, but from light itself. In the 1920s, a young astronomer named Edwin Hubble began using the largest telescope of his time, the 100-inch Hooker telescope at Mount Wilson Observatory, to photograph some of these spiral nebulae. He studied their stars carefully, searching for something specific, a type of variable star known as a Cepheid. These stars pulse with a regular rhythm, brightening and dimming over fixed periods. The relationship between their pulsation and true brightness allows astronomers to measure how far away they are. By finding Cepheids in the Andromeda Nebula, Hubble was able to calculate its distance. The result was astonishing, far beyond the edge of the Milky Way, over 2 million light-years away. The Andromeda Nebula wasn't part of our galaxy at all. It was a galaxy itself, an island universe of its own. That discovery changed everything. Overnight, the Milky Way lost its monopoly on the cosmos. The universe expanded from one galaxy to many. The spiral nebulae were revealed to be galaxies like ours, vast collections of stars, gas and dust, separated by unimaginable distances. What had once been faint clouds in the telescope eyepiece were now entire worlds. Humanity's place in the universe shifted again, just as it had when we learned the Earth revolved around the Sun. The cosmos had grown, and with it, our understanding of our smallness. It's difficult to overstate how profound that moment was. Imagine standing at the edge of the sea, believing the water before you was the whole world, and then learning there were other oceans, other shores, stretching endlessly in every direction. That's what it felt like for the scientists of that era. Hubble's work opened a new era in astronomy. The Milky Way was no longer the universe. It was a single galaxy among billions. The night sky, once thought to be a single structure, became a vast collection of galaxies scattered across space. After Hubble's discovery, astronomers began to catalogue galaxies systematically. They developed ways to classify their shapes: spirals, ellipticals, irregulars. Some were graceful and organised, others chaotic. Some were bright and young, others faint and ancient. As photographic technology improved, telescopes revealed more and more galaxies in every direction. No matter where they looked, the universe appeared filled with them. There was no center, no edge, just an endless field of light and distance. The realization brought new questions. If galaxies were scattered everywhere, how far did the universe extend? Was it infinite, or did it have boundaries beyond what we could see? To explore that, astronomers studied not just what galaxies looked like, but how they moved. By measuring the light from distant galaxies, they noticed something unexpected. The light was shifted toward the red end of the spectrum, a phenomenon known as redshift. It meant the galaxies were moving away from us, and not just a few of them, nearly all of them. The farther away a galaxy was, the faster it seemed to recede. Hubble once again pieced together the meaning of that discovery. The universe itself was expanding. That insight transformed our understanding of everything. The galaxies weren't moving through space. Space itself was stretching, carrying them apart. The universe wasn't static, as scientists had once believed. It was dynamic, growing, changing. This idea, born from careful observation of distant light, gave rise to modern cosmology, the study of the universe as a whole. Each galaxy became a marker, a point in a vast pattern revealing how the cosmos evolved over time. What began as curiosity about faint smudges had turned into the foundation of a new world view. Today, when astronomers point telescopes toward the deep sky, they see what Hubble saw, multiplied by 1,000. Every direction, every corner of the heavens reveals galaxies. Some are close and clear, their structures detailed. Others are faint whispers at the edge of visibility. Their light billions of years old. Each one carries information about the state of the universe when that light began its journey. The further we look, the younger the universe appears. Peering beyond the Milky Way is not just looking outward, it's looking backward in time. To imagine that is to stretch the mind almost to its limits. The light reaching us from the Andromeda Galaxy left when early humans were still shaping stone tools. The light from galaxies at the edge of observation began travelling before the Earth even formed. When we detect that light, we're not seeing the galaxies as they are now, but as they were then. They may have changed completely, merged with others, or vanished in collisions. Yet their ancient light keeps arriving, telling us stories from an unreachable past. The sky above is not a static picture. It's a time machine, showing us layers of history stacked upon each other in light. Beyond the Milky Way, the number of galaxies grows dizzying. Every improvement in our technology reveals more. The Hubble Space Telescope's deep field images, taken in the late 1990s, changed our understanding again. Astronomers pointed the telescope at what looked like an empty patch of sky, a region with no visible stars or known objects, and kept it fixed there for days, collecting light. The resulting image was staggering. That tiny patch, no bigger than a grain of sand held at arm's length, contained thousands of galaxies, each one a universe of its own. If such a small piece of the sky held so many, then the entire sky must contain hundreds of billions, perhaps even trillions. Peering beyond our galaxy is in many ways an act of humility. The more we see, the less central we become. The Milky Way, once thought to be the entire cosmos, is now just one pattern among many. Even the clusters of galaxies we find belong to larger structures, superclusters, filaments, walls, and between them are vast voids, empty regions millions of light years across. On the grandest scales, the universe forms a web of light, galaxies strung along invisible threads of dark matter. We can't see the dark matter itself, but we infer its presence from how galaxies move and cluster. It's the scaffolding of the cosmos, shaping everything we see. When we look outward, we also look inward. Every discovery beyond our galaxy reflects back on us, on how we see ourselves. The idea that we live in just one of billions of galaxies can feel overwhelming, but it can also be strangely comforting. The universe isn't empty, it's alive with structure, full of light, full of company. even if distant and unreachable. Somewhere in those other galaxies, stars are forming, planets are orbiting, perhaps life is emerging. The same physics, the same chemistry, the same patterns repeat everywhere. The Milky Way is unique, but it's not alone. It's remarkable to think that all of this, the vastness, the expansion, the tapestry of galaxies, was uncovered through light that barely reaches our eyes. Photons that left their sources billions of years ago still carry enough information to tell us where they came from and how they've travelled. When you see a faint galaxy in a photograph, you're seeing light that has journeyed across most of cosmic history. It's survived collisions, expansion, and time itself. It's fragile, and yet it endures. The same light falls now on your eyes, on your screen, connecting you directly to places you can never visit. Our understanding of galaxies beyond the Milky Way continues to evolve. The Hubble Space Telescope revealed the universe as a sea of galaxies. The James Webb Space Telescope is pushing that vision even further, peering deeper into time, seeing galaxies as they were only a few 100 million years after the Big Bang. Some of these early galaxies are surprisingly massive and bright, challenging our theories of how quickly such structures could have formed. Each observation forces us to revise our understanding, to refine our models. The universe keeps surprising us. Just when we think we've reached the edge, another layer appears, and yet no matter how far we look, there's always more beyond. The observable universe, the part we can see, is limited by the speed of light and the age of the cosmos. Beyond that horizon lies the unobservable, regions whose light hasn't had time to reach us yet. Those galaxies exist, but we can't see them. The universe we know is just a fraction of the whole. Even if we could count every galaxy in the observable realm, there would still be an infinity beyond our reach. It's a reminder that knowledge, like light, travels slowly, and that curiosity is a form of reaching outward into the dark. To peer beyond the Milky Way, then, is not just an act of science, it's an act of imagination. It asks us to picture what we cannot touch, to believe that what looks empty is filled with light too faint for our eyes. It asks us to remember that we live in a galaxy that once seemed like everything, but now feels like a single spark among countless others. And it invites us to keep looking, not to find an end, but to understand that the universe is an endless unfolding. Every galaxy we discover adds another thread to the cosmic fabric, another layer to the story of existence. The next time you find yourself outside on a quiet night, think of that. The faintest stars above you are part of the Milky Way, but beyond them, hidden in the darkness, lie billions upon billions of galaxies. Their light is arriving right now, softly, invisibly, whispering across the void. You can't see them, but they're there, forming the true backdrop of the universe. You are part of that view, a being of stardust, standing in one galaxy, looking out into a sea of others, listening to the silent conversation of light across time. For as long as people have looked up, they've wanted to count what they saw. It's a natural instinct, something woven into the way we make sense of the world. We count the days, the seasons, the stars we can name. We measure what we can reach and estimate the rest. Counting is a way of understanding, of building order out of the vastness. But when it comes to the universe, that habit meets its limit. Because once you start trying to count galaxies, you quickly realize that you're standing at the edge of the knowable. The numbers grow too large, the distance is too deep, and light itself becomes too faint. What began as a simple question, how many galaxies are there, turns into a meditation on the scale of existence itself. Even so, we've tried. From the moment we discovered that the Milky Way wasn't alone, that it was just one galaxy among many, scientists began trying to estimate how many others might be out there. Early on, in the 1920s and 30s, the guesses were modest. Maybe a few 100 million, some said, maybe more. But as telescopes improved, the numbers began to rise. Each new generation of instruments revealed more galaxies hiding in what had seemed like empty space. The deeper we looked, the more the universe revealed its abundance. it wasn't just filled with stars, it was filled with structures of unimaginable size and number. Counting galaxies is not like counting stars in the sky. You can't simply point a telescope, take a picture, and tally them up. The universe is three-dimensional, and every view we have is a layered one. Bright galaxies overlap faint ones. Dust hides entire regions. Distance dims the light until it vanishes entirely. Even the most powerful telescopes can only see a fraction of what's there. So astronomers rely on sampling, taking small portions of the sky, studying them deeply, and then extrapolating from what they find. It's a careful statistical process built on patience and precision. You look at a small piece of the cosmos, count everything within it, then multiply by the number of such pieces that would cover the whole sky. It's both simple and almost absurd in scale. In the 1990s, the Hubble Space Telescope gave us our first real glimpse of what deep means in cosmic terms. Astronomers decided to point the telescope at a region of the sky that appeared completely blank. No bright stars, no known nebulae, no visible galaxies, just darkness. They left the shutter open for days, collecting every photon that arrived. The result was the Hubble Deep Field image. In that single patch, no wider than a grain of sand held at arm's length, there were thousands of galaxies. Each one contained billions of stars. Multiply that across the entire sky, and the numbers became staggering. Hundreds of billions of galaxies within the observable universe, and that was only the beginning. Later, with improved sensitivity, the Hubble Ultra-Deep Field revealed even more. Fainter, smaller, older galaxies, their light stretched thin by the expansion of the universe. What these images showed wasn't just a count, they showed history. The galaxies in those pictures are not all the same age. Some are nearby, their light only a few million years old. Others are so distant that their light left when the universe was only a few 100 million years old. Looking at the deep field is like looking down a tunnel of time, each galaxy a different era. The farther away it is, the further back you're seeing. Some of those faint smudges are among the first galaxies ever formed, their light finally reaching us after travelling for over 13 billion years. Counting them is not just adding numbers, it's reading a timeline written in light. But even that incredible census doesn't capture everything. Telescopes like Hubble can only detect galaxies that are bright enough and close enough to be seen in visible light. Many galaxies are too dim, too dust-covered, or too far away. Others emit mostly infrared radiation, invisible to optical instruments. To see them, we need telescopes that look in other wavelengths. The James Webb Space Telescope, launched decades after Hubble, was designed for this. Its infrared sensors can peer through cosmic dust and detect the faint glow of galaxies at the edge of visibility. With its help, astronomers have already begun revising their estimates upward. What once seemed like an incomprehensible abundance now looks like a fraction of what truly exists. The latest estimates suggest that there may be 2 trillion galaxies in the observable universe. 2 trillion. The number is so large that it defies visualization. Each galaxy contains billions of stars, and each of those stars may host planets. Multiply those together, and you arrive at numbers beyond comprehension. Sextillions of worlds, each unique. But it's important to remember that even this number is limited by what we can see. The observable universe is not the whole universe. It's just the region whose light has had time to reach us since the Big Bang. Beyond that lies a vast realm forever hidden, beyond the reach of observation. Whatever galaxies exist there, we will never see them. They are part of the universe's mystery, real but unreachable. So when scientists say there are perhaps 2 trillion galaxies, they're talking only about the observable portion, the bubble of space about 93 billion light-years across that we can access through light. Beyond that, the universe continues, expanding, perhaps infinite. The total number of galaxies, if it could ever be known, might be many times greater. Or perhaps galaxies themselves become rare beyond a certain point, replaced by structures we can't yet imagine. Counting them isn't just a matter of numbers. It's a reflection of how far light has travelled, how much of the cosmic story we're able to read. One of the challenges in this counting is that galaxies come in many sizes and brightness levels. The brightest are easy to spot even at great distances, but most galaxies are small and faint, like cosmic plankton floating in the dark sea. They're called dwarf galaxies, and they outnumber the larger ones by far. Our own Milky Way has dozens of them as satellites, orbiting quietly around its edges. Some of them are so dim that they were discovered only in recent years. Others are known only through their gravitational effects. When astronomers model the universe as a whole, they find that these small galaxies make up the majority of all galaxies in number, even though they contribute only a small fraction of the total mass and light. Counting them accurately is one of the hardest problems in modern astronomy. Light itself becomes the limiting factor. The universe is expanding, and as it does, light from distant galaxies stretches into longer wavelengths. This redshift makes faraway galaxies dimmer and harder to detect. Eventually their light becomes so stretched that it moves beyond even infrared, fading into wavelengths we can't observe. Beyond that limit lies what's called the cosmic light horizon, the point beyond which light has not yet reached us. Those galaxies, if they exist, remain hidden, their light still on its way, crossing the expanding fabric of space. In a sense, the universe is larger than the part we can ever measure, and counting galaxies is like trying to measure the size of a room while standing in one corner with a small lamp. Even within the observable region, our instruments struggle to keep up with the faintest signals. Astronomers use techniques to infer what they can't see directly. They analyze the distribution of galaxies in deep surveys, measure their brightness functions, and use simulations of cosmic structure formation to estimate how many faint galaxies must exist below the detection threshold. These models are built on the laws of physics, tested against observations, refined over years. Every new telescope brings adjustments. Sometimes the estimates rise, sometimes they fall. The numbers change, but the awe remains constant. Whether there are hundreds of billions or trillions, the truth is the same. The universe is vast beyond any human scale. What's humbling is that even when we try to count galaxies, what we're really counting are the visible traces of something larger, the luminous knots in a web of matter that extends far beyond the reach of light. Most of the mass of the universe isn't in stars or galaxies at all. It's in dark matter and dark energy, invisible components that shape the large-scale structure of everything. Galaxies form along the filaments of dark matter, drawn by gravity into clusters and superclusters, so even when we count them, we're only counting the bright parts, the decorations on the deeper architecture of reality. There's another layer to this challenge, one that's not about light or distance but about perspective. From our position inside the Milky Way, we can't easily see outward in all directions. The dense plane of our galaxy blocks our view of certain regions, filled with dust and gas that obscure what lies beyond. To create a full census of galaxies, astronomers have to map around this zone of avoidance, a poetic name for the strip of sky hidden by our own galactic disk. Using radio and infrared observations, they fill in the gaps as best they can, but the picture will always have patches of uncertainty. Even our cosmic map has blind spots. The act of counting galaxies also reveals something about the way we think. We want definite answers, final numbers, totals we can hold in our minds. But the universe doesn't easily give us that. Its scale defeats precision. The more we learn, the more we realize that our measurements are always provisional, our models incomplete. Each discovery expands the boundaries of the possible. The phrase, counting the uncountable, isn't a contradiction. It's a description of science itself, a process of reaching further into what can never be fully known. Still, the numbers we do have carry meaning. When you hear that there may be 2 trillion galaxies, each with hundreds of billions of stars, you begin to sense the enormity of creation. The total number of stars in the observable universe might be around 10 to the 24th power, 1,000,000 trillion. It's a number so large it loses all familiarity. Yet it's not infinite. It's finite, measurable, if only in principle. That tension, between the knowable and the infinite, is part of what makes astronomy so compelling. We're creatures built to grasp small things, yet we find ourselves living in a universe that dwarfs every scale we can imagine. If you could see all the galaxies at once, every faint glow, every distant cluster, the sky would no longer look dark, it would be filled with light. The darkness between stars and galaxies exists not because space is empty, but because the light is too faint for our eyes to detect. In truth, the universe glows. Every direction is filled with radiation, from the faint hum of the cosmic microwave background to the soft glow of distant starlight. We live inside a faint, endless illumination, the combined light of uncountable galaxies washing across time. There's something deeply peaceful about that idea. It means that even the emptiest space is not truly empty. The photons from distant galaxies are passing through you right now, through the walls around you, through the planet beneath your feet. They are part of the quiet background of existence. Each one began in the heart of a star billions of years ago, escaped its galaxy, crossed the expanding universe, and arrived here, a faint whisper of the cosmos. When we count galaxies, we're counting the sources of those whispers, the places where light began its journey. It's easy to see why astronomers speak of humility when they talk about these numbers. To measure the universe is to confront our own limits. The tools we build, telescopes, detectors, computers, are extensions of our curiosity, fragile bridges into the vastness. Each improvement reveals more galaxies, more structure, more complexity. But it also reminds us that the universe is always one step ahead, always larger, always deeper. The act of counting becomes a dialogue between what we can perceive and what we can imagine. Somewhere, in the faintest reaches of the observable sky, there are galaxies whose light is just now arriving for the first time. Their photons have been travelling for almost the entire history of the universe, and only now, in this moment, do they touch our detectors. They carry information about the early cosmos, about how galaxies first formed, how stars began to shine, how matter gathered under gravity's pull. Counting them is not about reaching a total. It's about tracing that story, understanding how complexity arose from simplicity, how the smooth glow of the early universe became the intricate web we see today. The more we count, the more we realize that the universe is generous with its wonders. There's no shortage of galaxies, no lack of variation. Some are huge and bright, others small and faint. Some are alive with star formation, others are quiet and ancient. Each one adds to the total, and yet the total keeps slipping beyond the edge of knowledge. Perhaps that's the point. The universe was never meant to be fully tallied. It was meant to be experienced, explored, and wondered at. Counting is just our way of participating in that process, of bringing the infinite a little closer to our finite minds. If you could look out now, past the Milky Way, past Andromeda, past the clusters and superclusters, and see all the galaxies at once, you'd see not isolation, but connection. Every galaxy, no matter how distant, is linked to the others by gravity, by light, by history. The universe is a network of relationships, not a collection of separate things. To count galaxies is to acknowledge that web, to see yourself as part of it, because you are. You live in one of those galaxies, orbiting one of its stars made of the same atoms that shine in countless others. When you think about how many galaxies there are, you're also, in a quiet way, thinking about where you belong within them. And as we keep looking, as our telescopes reach deeper into the night, we'll keep refining that count. It will never be final. It will always be an approximation, a conversation between knowledge and mystery. But maybe that's enough. Maybe the act of counting, even when the total escapes us, is what connects us to the universe most deeply. To look into the dark and try to measure it is to participate in its unfolding, to turn curiosity into light. Somewhere beyond the faintest galaxies we can see, there are others, still hidden, still waiting. Their light is on its way, crossing the cold between stars, carrying the next clues, the next questions. When it arrives, we'll add them to the count, not to reach an end, but to continue the story. Because in the end, counting the uncountable is not about the total, it's about the wonder that keeps us counting. When the first images of the universe's deep field were captured, the world changed in a way that was quiet but irreversible. It wasn't a loud discovery, not the kind that makes headlines overnight. It was a long, patient act of looking. Astronomers had pointed a telescope toward what seemed to be nothing, an empty patch of darkness in the sky near the handle of the Big Dipper, a place without any stars bright enough to be seen by human eyes. They left it there, unblinking, for days, gathering light photon by photon. There was no guarantee anything would appear. Many thought it would be a waste of time. But when the final image came into focus, what emerged from that darkness was beyond expectation. The so-called emptiness was full. Thousands of galaxies, each one distinct, glowing faintly from billions of light years away. That single picture became one of the most profound views ever taken. It showed that no part of the sky is truly empty. Every tiny fraction of darkness contains an unimaginable abundance of light. That image was called the Hubble Deep Field. It was taken in 1995 by the Hubble Space Telescope, which orbits Earth far above the distortion of the atmosphere. The decision to take it was a bold one. Telescope time in orbit is precious, and spending so many days staring at a small, blank region of sky was controversial, but the risk paid off. What the telescope revealed in that small window was a sample of the universe as it really is, filled in every direction with galaxies, spirals, ellipticals, irregular smudges, faint red dots, bright blue swirls, all crowded together in a seemingly chaotic tapestry. Some were nearby, others so distant that their light had been travelling since the early days of the cosmos. Each one was a system of billions of stars, and together they formed a picture of the universe that no one had ever truly seen before. The first reaction from many scientists was disbelief. The scale was overwhelming. That image represented a fraction of the sky so tiny that you could cover it with a single grain of sand held at arm's length. If such a small patch contained thousands of galaxies, then the entire sky must contain hundreds of billions, maybe more. The universe, it turned out, was not just large, it was saturated with structure. Wherever you look, galaxies fill the view, stretching in every direction as far as light can reach. The deep field turned abstract numbers into something tangible. It made the immensity visible. When you look at that image, and it's worth imagining it even now, you're seeing time layered upon itself. The galaxies in the foreground are relatively close, maybe a few 100 million light-years away. Those in the middle distance are older, their light stretched by the expansion of the universe, and those faintest, reddest smudges near the edge of visibility are the most ancient of all. Their light began its journey more than 13 billion years ago, not long after the universe itself began. Each pixel of that photograph is a record of time. To look at it is to look backward through the entire history of the cosmos. The image is not just a portrait of space, it's a timeline of creation. Later, astronomers repeated the experiment, refining it, going deeper still. The Hubble Ultra Deep Field in 2004 and later the Extreme Deep Field in 2012 pushed the limits of observation further than ever before. The total exposure time for those images was measured in weeks. Every photon that reached the telescope's sensors had travelled for billions of years, and yet, there it was. Light arriving, steady and delicate after crossing most of the known universe. In those pictures, the number of galaxies rose again. Some were so far away that they existed when the first stars were just beginning to ignite. Their light was faint, stretched into the red and infrared parts of the spectrum, almost lost to time, but not lost entirely. The telescope caught them, the earliest glimpses of galaxies in formation, glowing with the heat of newborn stars. What those images revealed was more than beauty. They showed evolution. In the nearest galaxies, spirals and structured disks dominate, mature systems with billions of years of history, but in the farthest oldest ones the shapes are irregular and clumpy. These are the first galaxies still assembling, merging and forming stars at incredible rates. They are snapshots of cosmic youth. By comparing them, scientists can trace how galaxies grew and changed, how the smooth glow of the early universe transformed into the complex web of stars we see today. The deep field images are like pages in the universe's photo album, each one capturing a different stage of development. It's hard to convey what it feels like to see those images for the first time, even through a screen. The colours are subtle, the shapes small and distant, but the meaning is immense. You're looking at light that has travelled across nearly all of time. You're seeing the universe not as it is, but as it was. Every dot of colour is a galaxy, each one home to billions of suns. Some of those suns may have planets, some of those planets may have oceans, and on some of those, perhaps, there might be beings who have looked up at their own night skies, wondering if they are alone. The deep field is not just an image, it's a bridge of light between what exists here and what existed there, between now and then, between one tiny corner of the cosmos and all the others. When astronomers study the deep field, they measure more than beauty. They extract data, the brightness, colour and redshift of each galaxy. These numbers tell stories about distance, age and composition. They show how galaxies formed stars faster in the early universe, and how that rate declined over time. They reveal the role of dark matter in shaping the distribution of galaxies, the filaments and voids that make up the cosmic web. Each faint smudge becomes a data point in a grand pattern, a clue to how everything came to be. Counting them, cataloguing them, analysing them. It's an act of science, but also one of reverence, because behind every calculation lies a sense of awe that numbers alone can't contain. Even with all this data, the deep field doesn't show everything. There are galaxies too faint, too far, or too hidden in dust for Hubble to detect. That's where the next generation of telescopes comes in. The James Webb Space Telescope, launched decades later, was designed to see even deeper, not just in space, but in time. Its infrared sensors can capture light that has been stretched so much by cosmic expansion that it no longer appears in visible wavelengths. When Webb aimed its mirrors at similar regions of sky, it saw galaxies that Hubble couldn't. Tiny red smudges representing some of the first galaxies ever formed. Some of them existed less than 500 million years after the Big Bang. Their light has been travelling for over 13 billion years to reach us. To see them is to witness the dawn of structure itself, the first gatherings of stars in a universe just beginning to cool. The sight of those early galaxies challenges our understanding. They appear more numerous and massive than models predicted. It suggests that the universe may have formed stars and galaxies faster than we thought possible. Each new observation forces scientists to refine their theories, to revisit their assumptions about how matter assembled after the Big Bang. The deep field is not just an answer, it's a question, one that keeps unfolding the more we look. It's proof that the universe is still full of surprises, that the edge of knowledge keeps moving outward. There's something deeply human about the decision to stare at nothing and wait for light. It's an act of patience, of faith in discovery. The Hubble Deep Field wasn't about chasing what was already known. It was about trusting that the unknown had something to show us if we were willing to look long enough. And it did. The image it produced changed not just astronomy, but our sense of place. It showed that we are part of a universe that is overwhelmingly full of galaxies, of light, of history. The empty sky is an illusion. The darkness we see is only the limit of our vision. If you were to take that image, hold it up against the night, and imagine it repeated across the entire sky, you'd begin to sense the scale. Every point, every inch of darkness above you contains thousands upon thousands of galaxies, each one a separate world of stars. and between those galaxies stretches the vastness of space, mostly empty but connected by the faint threads of gravity. The deep field teaches us that the universe isn't made of emptiness and light. It's made of light in waiting, light that hasn't yet reached us, light that may never reach us. It's a living sea, where every drop holds stories billions of years old. Astronomers sometimes speak of the deep field as a glimpse into infinity, though the universe itself may not be infinite in a strict mathematical sense. What they mean is that the image gives us the closest thing to it that we can experience, a visual impression of endlessness. When you look at it, your eyes move from one galaxy to another, and there's never a final one. There's no boundary, no horizon, no sense of completion. It goes on, smaller and fainter, deeper and older, until vision itself gives out. The image captures not the infinity of space, but the infinity of wonder. It's a reminder that the universe is not something to be finished or contained. It's something to be encountered, one layer at a time. The deep field also tells us something subtle about perspective. It shows that the universe looks the same in every direction, no matter where we point our instruments. This uniformity, called isotropy, is one of the great truths of cosmology. It means there's no privileged place in the cosmos. The same abundance of galaxies appears in every patch of sky. No matter where you are, no matter which direction you look, the story is the same. The universe doesn't favour one viewpoint over another. We're not at the centre. We're simply in it, looking outward from one location among uncountable others. There's a quiet beauty in that realisation. It's the ultimate levelling truth. We belong to everything, and everything belongs to us. In that sense, the deep field isn't just an astronomical image, it's a philosophical one. It shows what happens when curiosity meets patience, when technology extends the reach of imagination. It's a collaboration across generations, the product of centuries of questions, of lenses ground by hand, of equations scribbled in notebooks, of rockets launched through the atmosphere. Every pixel in that image is the result of human persistence, and every photon in it is the result of cosmic persistence. Light travelling for billions of years without faltering, carrying the message that existence endures. If you were to hold a printed copy of the deep field, you might notice how small it seems, a square of faint specks, most of them barely visible. But when you understand what you're looking at, the scale changes. Each dot becomes a galaxy. Each galaxy becomes a universe of its own. It's like holding infinity in your hands. The image condenses everything, time, distance, and creation, into something small enough to contemplate. That's what makes it so powerful. It bridges the vast and the intimate. It reminds you that the entire universe, with all its galaxies, can fit into the field of a camera and into the space of your mind. The deep field continues to inspire because it embodies the best of what we can do. The willingness to look deeper, to wait longer, to find meaning in faint signals. It's not just a scientific achievement. It's an act of wonder turned into data. Every time a new telescope points its mirror toward the same region, we see a little more, understand a little better, but the feeling remains the same. That quiet astonishment. That sense that we are peering into forever. The deep field doesn't end when you stop looking at it. It lingers, changing the way you see the night sky itself. The darkness no longer feels empty. It feels full of galaxies, full of stories, full of time. And perhaps that's the deepest truth it offers. The universe doesn't hide its wonders. It displays them openly, in every direction, waiting for eyes and instruments capable of seeing. The deep field is proof that looking into the void reveals not absence but abundance. It's a window, and through it we see not just galaxies but ourselves. Creatures who can build tools to capture light older than our world, who can transform that light into understanding. Every photon in that image is a conversation between the universe and consciousness. between what exists and what knows it exists. So when you think of that picture, think of what it means. Somewhere, beyond all that darkness, the light from other galaxies is still on its way. It will arrive in the future, perhaps long after we're gone, and someone else or something else will look at it and marvel. The deep field isn't the end of discovery, it's the beginning of endless seeing. It reminds us that infinity isn't out there, unreachable. It's here, unfolding every time we look a little longer, wait a little more, and let the universe reveal what it has always been willing to show. Counting what we can see is difficult enough. Counting what we cannot touch, what we cannot even truly see, demands something else entirely. It asks for trust in light, in physics, in the long chain of reasoning that connects what happens in a telescope to what exists across billions of light years. It's a strange kind of work, both abstract and intimate. To count galaxies, astronomers don't reach out and gather them like shells from a beach. They collect light, thin, ancient light that has crossed the void. That light becomes numbers, the numbers become maps, and the maps become meaning. It's an act of reconstruction, like trying to rebuild a forest from the shadows of its trees. When we think about counting galaxies, we picture images like the deep field, beautiful, filled with colour and form. But behind those images lies the real labour of measurement. The faint light of a distant galaxy may be only a handful of photons, arriving one by one over hours or days. Each photon is recorded by detectors that turn it into an electronic signal. Computers process those signals, filtering out noise, calibrating brightness, correcting distortions caused by optics or atmosphere. Then software identifies shapes, slight variations in brightness across the field. Those shapes are compared against models to decide which ones are galaxies, which are stars, which are artifacts of the instrument itself. Only after that long chain of work does a single dot of light become part of the count. What's remarkable is how much information can be extracted from such faint traces. A galaxy billions of light years away may appear as a blur, yet its spectrum, the detailed breakdown of its light by wavelength, reveals its distance, its motion, even its chemical composition. Light that has travelled for 13 billion years still carries the signature of the elements that created it: hydrogen, helium, traces of oxygen and carbon, the fingerprints of stars. By studying how that light is stretched, scientists can measure how fast the galaxy is receding, which in turn tells them how far away it is. The farther the light has travelled, the redder it becomes, its wavelength stretched by the expansion of space. That shift is the cosmic yardstick, the ruler by which the universe is measured. To turn those distances into numbers of galaxies, astronomers rely on surveys, systematic scans of the sky designed to map its contents. These surveys use wide-field telescopes that can capture enormous sections of the heavens in a single exposure. Each survey produces terabytes of data, far too much for any one person to examine. Algorithms sift through it, cataloguing billions of points of light. Some surveys focus on visible light, others on infrared or radio waves. Each wavelength reveals a different population of galaxies. Visible light shows young, bright galaxies forming stars. Infrared reveals older, dust-obscured ones. Radio waves uncover massive structures where gas is still gathering. Combined, they give a fuller picture, a kind of multi-layered census of the cosmos. But even the most complete map is only a sample. We can't observe the entire universe directly, not even the whole sky. So astronomers use what they see to infer what they can't. They measure how many galaxies exist in a given volume of space, then multiply that by the size of the observable universe. It's a simple idea, yet the execution is anything but simple. The density of galaxies isn't uniform. Some regions of the universe are rich with clusters and filaments, others are vast voids, almost empty. To estimate accurately, scientists have to understand that structure, how galaxies are distributed across scales. They model it using simulations that recreate the universe from its earliest moments, starting with the tiny fluctuations in matter after the Big Bang. These simulations follow the pull of gravity over billions of years, showing how matter gathers, how dark matter forms scaffolds, and how gas condenses into stars and galaxies. By comparing these simulated universes to real observations, astronomers refine their estimates. If the number and distribution of galaxies in a model match what we see, the model is likely close to reality. If not, the physics must be adjusted. The properties of dark matter, the rate of cosmic expansion, the feedback from star formation. It's an iterative process, a conversation between theory and observation that never really ends. Every deep field, every survey, every new telescope adds another layer of detail, another constraint. Bit by bit, the invisible becomes visible, the untouchable measurable. There's something quietly poetic about the way this works. The tools we use to study the universe are built from the same matter the universe studies itself through us. Metal mined from Earth becomes a mirror that catches light from galaxies older than our planet. Computer chips made of silicon process signals from stars born long before the solar system formed. We use atoms forged in ancient stars to understand those very stars. The act of counting galaxies is not just observation, it's participation. Matter learning about itself through reflection and patience. To count what we cannot touch, we also have to think differently about what seeing means. Our eyes evolved to handle a narrow band of light, a small window within the electromagnetic spectrum. But the universe radiates across a vast range of wavelengths, from radio waves the size of buildings to gamma rays smaller than atoms. Most galaxies emit light across all these bands. To capture their full story, we need instruments tuned to each one. Radio telescopes listen to the long, low whispers of hydrogen gas. Infrared telescopes see through dust to the hidden regions where stars are forming. X-ray observatories detect the violent hearts of galaxies, where black holes consume matter and emit powerful radiation. Each type of telescope adds a new voice to the cosmic symphony. Counting galaxies isn't just counting points of light, it's listening to the full spectrum of existence. Consider, for example, how astronomers identify galaxies that are invisible in visible light. These are sometimes called dark galaxies, not because they contain dark matter alone, but because they produce little or no starlight. They may be composed mainly of gas, or their stars may be hidden by thick dust. Detecting them requires radio observations of the hydrogen line, a faint signal emitted by neutral hydrogen atoms. By scanning the sky for that specific frequency, scientists can map where gas collects, even when no light escapes. These hidden galaxies are part of the count, part of the unseen majority that fills the cosmic ledger. Without them, our picture of the universe would be incomplete. There's also the challenge of distance. Light from nearby galaxies reaches us almost unchanged, but the light from faraway ones arrives red-shifted, dimmed and stretched. To interpret that light, astronomers must correct for the effects of cosmic expansion. The further away a galaxy is, the more its light is shifted, the more uncertain its exact distance becomes. Measurements must account for how fast the universe expands, how gravity warps space, and how the distribution of matter affects the path of light. The mathematics of these corrections is complex, but the principle is simple. The universe is dynamic, and the light we see carries that dynamism encoded within it. Each photon is not just a point in space, it's a record of motion, of change, of time itself stretching. The act of counting galaxies is also an act of perspective. We count from within one galaxy, looking outward. Our position defines what we can see. The Milky Way's disk hides some directions from view, and our instruments have limits. What we call the observable universe is bounded not by walls but by time, by the distance light has travelled since the beginning. Beyond that, galaxies exist, but their light hasn't reached us yet. In principle, We could imagine an infinite universe, filled with infinite galaxies, but infinity cannot be counted. So we settle for the part we can measure, knowing it's only a fragment of the whole. What's beautiful is that even this fragment is enough to reveal patterns that repeat everywhere. Galaxies gather into clusters, clusters form superclusters, and those connect into filaments. The arrangement looks random at first glance, but zoom out far enough and a hidden order appears. The universe, on large scales, looks the same in every direction, a self-similar pattern of structure. The same physics that shapes galaxies near us shapes those at the edge of visibility. When we count them, we're counting not just objects but repetitions, the echo of the same laws unfolding over and over across the cosmos. To get a sense of how this works in practice, imagine an astronomical survey like the Sloan Digital Sky Survey, a project that has mapped millions of galaxies across a quarter of the sky. Its telescope, operating from New Mexico, sweeps systematically through the heavens, capturing spectra for each object it sees. Each spectrum is like a barcode, unique to that galaxy, encoding its distance, motion, and makeup. The result is a three-dimensional map of the universe, not a flat image, but a volume filled with galaxies, each one a point of light in space and time. When you visualize that data, the universe looks like a vast web, with filaments stretching across billions of light years. It's not a flat canvas, it's a living structure, dynamic and interconnected. Those maps are among the most humbling things humans have ever created. They show our position within a network of unimaginable size. They reveal that the Milky Way is part of a small group of galaxies which sits on the edge of a supercluster, which itself is a tiny node in a structure that extends as far as we can measure. When we talk about counting galaxies, that's what we mean. Not just tallying numbers, but understanding how those numbers fit into a pattern. It's about tracing the architecture of existence. Even with all this data, uncertainty remains. The faintest galaxies slip through the cracks, hidden by distance or dust or faintness. To estimate their numbers, astronomers use statistical models. They look at how the brightness of galaxies is distributed, how many are bright, how many are faint, and extrapolate that distribution to levels we can't yet observe. It's like listening to the tail of a fading echo and guessing how long the sound continues beyond hearing. These extrapolations suggest that most galaxies are faint, small, and easily overlooked, the cosmic equivalent of background noise. Yet together, they outnumber the bright ones by a wide margin. The universe, it seems, is made mostly of the faint and the forgotten. When we count what we cannot touch, we also confront the limits of human senses and machines alike. The deeper we look, the more the signal fades into noise. At some point, the photons arriving from distant galaxies are so few that they blend with the random fluctuations of the detectors themselves. Distinguishing real light from electronic noise becomes an art as much as a science. Teams of researchers check and recheck each detection, comparing it against expectations, verifying that what they see is not a trick of the instrument. Each confirmed galaxy is a victory, not just over distance, but over entropy, over the quiet tendency of the universe to blur its details into uniformity. All of this, the surveys, the simulations, the calibrations, exists because we can't go there. We can't reach out and hold a galaxy, can't bring back samples, can't test its stars in a lab. All we have is light. But light is enough. It carries within it the memory of where it came from, the story of its journey. When you analyze that light, you're touching something real, just in a different way. The photons that enter a telescope mirror tonight may have left their source before the Earth had formed. They've travelled across expanding space, through intergalactic dust, past countless other galaxies, and ended their journey here, on a detector built by human hands. That's what it means to count what we cannot touch. It's to translate the untouchable into something knowable, one photon at a time, and perhaps that's the quiet magic of it. The The universe doesn't give up its secrets easily, but it doesn't hide them maliciously. They're there, waiting, written in light. The tools we've built are our way of listening. Each observation adds a brushstroke to the grand portrait. We may never finish it, but we don't need to. The act of painting is enough. The counting is not an attempt to capture the whole, but to participate in it, to acknowledge that we too are part of the pattern. If you step outside now, you won't see most of what's out there. The galaxies are too faint, their light drowned by the atmosphere, by city glow, by distance itself. But they are there, scattered across the sky, their photons still arriving. The telescopes on mountaintops and in orbit are simply extensions of your own eyes, built to stretch your reach across space and time. Through them, humanity has found a way to touch the untouchable, to measure the immeasurable, to count what was once beyond imagination. And as our instruments grow sharper, our detectors quieter, our algorithms wiser, we will continue to count, not to reach a final number, but to refine our understanding of how vast the uncountable truly is. The galaxies are out there, waiting, and so are we, patient as light, listening for their faint, steady signals in the dark. When you think about the number of galaxies in the universe, the words themselves start to lose meaning. Billions upon billions. It sounds vast, but still somehow manageable, as if the number could be written down on paper, counted, contained. But when you stop and really try to grasp it, the scale collapses comprehension. 1 billion is 1,000 million, and each galaxy holds billions of stars. The universe, then, contains more stars than there are grains of sand on all the beaches of Earth. It's a phrase often repeated because it feels almost comforting to compare cosmic numbers to something familiar. But even that comparison doesn't do it justice. A grain of sand is something you can hold in your hand, a single piece among many. The stars, the galaxies, the light, those aren't objects scattered in space. They're parts of a structure so enormous and intertwined that the mind can't hold it all at once. Astronomers often use the phrase billions upon billions, not as an exact measure, but as an acknowledgement of that limit. It's a way of saying there's more than we can count, more than we can know, and that every new discovery only expands the total. Each new telescope, each deeper field, adds to the sum. The number of known galaxies has climbed steadily as our instruments have improved. What once seemed like the entire universe now feels like a small corner of it. The more we look, the more the universe reveals that it's overflowing. Not empty, but full beyond imagination. When Edwin Hubble measured the distance to the Andromeda Galaxy a century ago, the universe expanded overnight from one galaxy to many. Since then, it has grown again and again, not in physical size, though space itself is expanding, but in our awareness of its content. The first catalogues listed hundreds of galaxies, then thousands, then millions. Now, with surveys that scan the sky digitally, we count them in the billions. The Sloan Digital Sky Survey alone has mapped over 1 million galaxies in 3 dimensions, each one a separate world, and that's just a small fraction of the sky. Extrapolate that to the entire observable universe, and the total climbs to hundreds of billions, perhaps even a few trillion. It's a number so large that it becomes almost philosophical. Every one of those galaxies is different. Some are massive spirals with well-defined arms, glittering with young blue stars. Others are old and red, their star formation long finished, drifting quietly through space. Some are so faint that their combined light barely registers on our instruments. Others shine so brightly that they outshine everything around them. They come in clusters and filaments, in groups and pairs, sometimes colliding, sometimes alone. Together they form a population as varied and dynamic as the life that evolved within one of them. The phrase billions upon billions is not just about number, it's about diversity. The endless variation that arises when the universe has enough time and matter to experiment. If you imagine the universe as a vast city, galaxies are its lights, countless, scattered across every direction. From far away, the city glows as one. its lights blending into a faint diffuse radiance. But up close, each light has its own texture, its own rhythm. The galaxies are like that. To the eye of a distant observer, the universe might look like a smooth, glowing fog. But zoom in, and structure appears. Clusters of galaxies connected by invisible threads, separated by dark, empty voids. The galaxies gather like neighborhoods in a sprawling metropolis, linked by gravity's pull. And just like cities, they change over time. Some grow, some fade, some merge. The universe is not static. It's alive with motion and evolution, even if that motion happens on scales too vast for us to notice. When we talk about billions of galaxies, we're also talking about billions of histories. Each one has its own beginning, its own sequence of births and deaths, its own moments of creation and collapse. Some formed quickly after the Big Bang, their stars blazing bright in the early universe. Others formed slowly, assembling from smaller fragments over billions of years. Each one carries the record of its life in its light. The colour, brightness, and shape of a galaxy are all clues to its past. A blue irregular galaxy is likely young, still forming stars. A red, smooth one is older, its star-making days behind it. Astronomers read these colours the way historians read old manuscripts. Each galaxy is a story written in starlight, and the universe is a library with trillions of such books. The sheer number of galaxies also forces us to think differently about time. The light we see from the nearest galaxies is already ancient, millions of years old. The light from the most distant ones left when the universe was young, over 13 billion years ago. When you look at a galaxy through a telescope, you're not seeing it as it is now, but as it was then. Each one you observe exists at a different moment in cosmic history. Together they form a timeline of the universe itself. To look at billions of galaxies is to look at billions of versions of the past, each one a frame in the long film of cosmic evolution. And yet, despite the numbers, the universe remains strangely quiet. The distances between galaxies are enormous, so large that even light, the fastest thing we know, takes millions of years to travel from one to another. Collisions do happen, but they unfold slowly, over hundreds of millions of years, too gradual to watch in real time. From our perspective, the galaxies are frozen, suspended in their vast separations. But in reality, everything is moving. The Milky Way is racing through space at hundreds of kilometers per second. So is Andromeda. So are the countless others. The whole universe is in motion, expanding, drifting, colliding, and reforming, though we perceive it as still. The numbers remind us that what seems eternal is always in flux. What's truly extraordinary is that these billions of galaxies all obey the same laws. Gravity, electromagnetism, nuclear fusion. The same principles govern every star, every cluster, every spiral arm. The physics that operates in our own galaxy operates in all of them. This uniformity gives us confidence that when we study one corner of the cosmos, we're learning about all of it. The laws are universal. They apply equally to the nearest star and to the most distant galaxy we can see. The phrase billions upon billions becomes not just a statement of quantity, but of connection. The same patterns repeat, scaled up, echoed across light years. Even so, there's something deeply human about our desire to put numbers to the infinite. We measure, we estimate, we extrapolate, knowing that the total will always elude us. Counting galaxies isn't really about reaching a final number. It's about exploring the limits of what can be known. The process itself is an expression of curiosity, a way of touching the universe through understanding. When Carl Sagan spoke of billions upon billions, he wasn't only describing quantity, he was describing wonder, that endless sense of awe that comes from realizing how much there is and how small we are within it. If we could somehow travel outward, past the Milky Way, past the local group, into the wider expanse, we would see this abundance directly. The galaxies would fill every direction, glowing faintly against the black. Some would appear as thin disks, others as glowing ellipses. The light between them would grow richer, layered, overlapping. You would see clusters, immense gatherings of thousands of galaxies bound by gravity, and beyond them, filaments stretching for hundreds of millions of light years. The voids between these structures would seem empty, but even there, faint galaxies drift, scattered like dust motes in sunlight. The phrase billions upon billions is not hyperbole, it's literal. The universe is full to overflowing, and yet, for all its vastness, it still feels strangely personal. Every one of those galaxies contains the same ingredients that make up you: hydrogen, helium, carbon, oxygen, iron. The same processes that light their stars once shaped your atoms. When you breathe, the oxygen that enters your lungs was forged in ancient supernovae, perhaps in galaxies long vanished. The same light that fills the cosmos fills you. In that sense, the billions of galaxies are not just out there, they're also within you, reflected in your chemistry, in the particles that make up your body. The universe repeats itself at every scale. It's humbling to realize that even with billions of galaxies, the universe may not be infinite in age or space. The observable portion has an edge defined by time, about 13.8 billion years since the Big Bang, though because of expansion, the farthest galaxies we can see are now around 46 billion light-years away. Beyond that, we can't observe, but the pattern likely continues. The same web of galaxies, the same structures, stretching into distances beyond reach. In that sense, billions upon billions is a kind of refrain, a way of acknowledging that the universe has no clear boundary. There is always more beyond the horizon. Every new telescope pushes that horizon back a little further. The James Webb Space Telescope, with its deep infrared vision, has already revealed galaxies that existed only a few 100 million years after the universe began. Some of them are unexpectedly bright and massive, suggesting that galaxies may have formed faster than we thought possible. If those findings hold true, then the total number of galaxies in the early universe was even higher than current estimates suggest. Over time, many of those early galaxies merged or faded, reducing the number visible today. The universe began crowded and bright, then thinned and expanded, leaving vast spaces between galaxies. Counting them is not just counting objects in space, it's tracking how structure changes across time. Astronomers use these observations to build what's called the luminosity function, a statistical distribution showing how many galaxies exist at each brightness level. By integrating this function, they can estimate the total number of galaxies at different epochs. The results tell a story of abundance and evolution. In the early universe, small, faint galaxies dominated. Over billions of years, they merged to form the larger ones we see today. The total number of galaxies has decreased, but their average size has grown. The universe trades quantity for complexity, simplicity for structure. It's a process that mirrors evolution in other forms, not biological but cosmic. And still, even with all that data, the full count remains out of reach. There are galaxies so faint that their light will never reach us, lost to the expansion of space. There are others hidden behind the dust lanes of our own Milky Way, invisible in optical light. There are even more that exist beyond the observable horizon, their light forever outpaced by the universe's growth. Billions upon billions is not a ceiling, it's a window. It tells us that what we know is only a fraction of what there is, and that discovery is not a path toward completion, but toward greater wonder. Sometimes, when astronomers discuss these numbers, they sound almost reverent. The language of science turns quiet, almost meditative. The sheer magnitude leaves little room for anything else. The cosmos isn't something to conquer or master. It's something to listen to observe, to join in the act of being. The galaxies aren't distant curiosities. They're expressions of the same physical laws that shaped us. Counting them is an act of recognition, acknowledging that we live in a universe that overflows with possibility. The next time you step outside at night, try to imagine it. The faint stars above you belong to our galaxy, but beyond them, stretching in every direction, are billions of others. Every patch of darkness, every space between stars hides them. They're too far and too faint to see, but they're there, filling the universe like silent witnesses. Their light is still travelling, still crossing the void, still adding to the sum of what exists. When you look up, you're not seeing an empty sky. You're seeing the thinnest layer of an ocean so deep it never ends. The phrase billions upon billions isn't meant to intimidate or overwhelm. It's meant to remind you of scale, not just the scale of the universe, but the scale of understanding. The fact that we can even estimate such numbers is extraordinary. The universe didn't make itself simple for us. Yet somehow, through observation, patience, and imagination, we've managed to glimpse its structure. We've counted enough to know that counting will never be complete, and that's a kind of victory. To know there's always more is to know that curiosity will never run out of sky. In the end, the numbers fade and what remains is the image. Countless galaxies, scattered across time and space, glowing in every direction. They exist not just as data points or distant objects, but as parts of a larger whole, one that includes you. The same processes that made you. The same light that fills them reaches you. Billions upon billions of galaxies, billions upon billions of stars, and one consciousness aware enough to notice. That's the real miracle, not the quantity, but the connection. And so, the counting continues. Each telescope adds another layer, each photon another clue. The total grows, but the wonder grows faster. The universe keeps offering more, and we keep looking deeper, guided not by the hope of finishing, but by the quiet joy of knowing there's always something left to find. For all the galaxies we've discovered, for every glittering spiral and glowing core that fills our telescopes, there are others that remain invisible. Not because they're far away, but because they hide in the dark. They exist in silence, made of matter that gives off no light, that neither glows nor reflects, that passes through space unseen. These are the galaxies we can't look at directly, the ones that live in shadow. And though we can't see them, we can feel their presence. They pull on the galaxies we can see, distort the paths of light, and shape the very structure of the universe. They remind us that most of what exists is hidden. When we look at the night sky, we're seeing only a small fraction of reality. The stars, planets, and galaxies that shine make up less than 5% of the universe's total content. The rest is invisible. Roughly 27% is something called dark matter, and nearly 70% is an even more mysterious force known as dark energy. Together, they dominate the cosmos, determining its structure and fate. The galaxies we see are like islands of light, floating in an unseen ocean, shaped and sustained by the dark currents beneath them. The concept of dark matter emerged from a simple observation. When astronomers measured how fast galaxies rotate, they found something strange. The stars at the edges of galaxies move too quickly. According to Newton's laws, the visible mass of the stars, the gas, the dust, wasn't enough to hold them in orbit. By all accounts, those galaxies should have torn themselves apart. And yet, they remained intact. The only explanation was that there was more matter present than what we could see. Invisible mass adding gravity to hold the galaxies together. This unseen substance became known as dark matter. It's one of the most profound discoveries in modern science, not because we've detected dark matter directly, or we haven't, but because its presence can be measured through its effects. Light bends as it passes near massive objects, a phenomenon known as gravitational lensing. By studying how light from distant galaxies is distorted as it travels toward us, astronomers can map where the hidden mass lies. The results are striking. The visible galaxies trace only part of the cosmic structure. Around and between them are vast halos and filaments of dark matter, stretching across the universe like a web. The galaxies we see are simply the brightest nodes on that invisible lattice. Within our own galaxy, dark matter surrounds us. The Milky Way is embedded in a halo of it, extending far beyond the visible disk of stars. We move through this invisible field constantly, unaware. Dark matter doesn't interact with light or ordinary matter in any significant way, so it passes through everything, planets, people, telescopes, without leaving a trace we can detect, except through gravity. It's as if we live inside an invisible architecture that holds everything in place. The stars, the gas, the planets, even the shape of the galaxy itself. All of it is determined by this unseen scaffolding. If dark matter vanished, galaxies would unravel, the stars would drift apart, the cosmic web would dissolve, and the universe would look nothing like it does now. Light alone can't create structure on the scales we see. The dark provides the framework. It's ironic, really, that what we call dark matter is what gives the universe its shape, its texture, its ability to exist in the way it does. The light we see, beautiful and familiar, is only the decoration on a much deeper pattern. And yet, for all our understanding of its effects, we still don't know what dark matter actually is. It's not made of atoms, it doesn't emit radiation, it doesn't collide or clump in the same way normal matter does. The leading theories suggest it might be composed of exotic particles, weakly interacting massive particles or WIMPs, or perhaps axions, or something even stranger we haven't yet imagined. Experiments deep underground and in space are searching for these particles, trying to catch the faintest whisper of interaction. So far, nothing conclusive has been found. The universe is keeping its secret well. There are even galaxies made almost entirely of this hidden substance. Astronomers have discovered systems where stars are sparse, but gravitational effects are strong, suggesting that the visible matter is only a thin trace on top of a vast dark foundation. These dark galaxies contain few stars, yet they move as if filled with enormous amounts of mass. In some cases, they barely glow at all, detectable only through the gravitational lensing of background light. They're like ghosts, shapes in space inferred from the way they bend what passes behind them. In recent years, the story has become even stranger. Some galaxies appear to have less dark matter than expected, or even none at all. These exceptions challenge our models, suggesting that dark matter might not distribute itself uniformly. Perhaps it clumps differently under certain conditions. Perhaps it interacts weakly in ways we don't yet understand. The truth may be more complex than any single theory can capture. Each discovery adds a new piece to the puzzle, but the picture remains incomplete. It's tempting to think of the dark as empty, as absence. But in the universe, darkness is substance. It's what holds everything together. The galaxies that hide in the dark aren't failures of detection. They're signs of a universe that operates on levels beyond human senses. Light is rare, fragile, temporary. Darkness is the rule, the background, the constant. Without it, there would be no stars, no galaxies, no us. Even the light we do see is shaped by the dark. When we look at the cosmic microwave background, the faint afterglow of the Big Bang, we see small fluctuations, tiny differences in temperature and density. Over billions of years, those fluctuations grew under the influence of dark matter. Gravity pulled matter into denser regions, forming the first galaxies along invisible threads. Without dark matter, those fluctuations would have remained smooth. The universe would have stayed a glowing fog, never condensing into stars or planets. Darkness, not light, is what gave birth to structure. Imagine standing outside on a clear night. The stars are scattered across the sky, bright and distant. Between them lies blackness, the empty-looking space that seems to stretch forever. That blackness isn't nothing. It's the presence of everything that doesn't shine. The galaxies that hide there, the halos of dark matter, the voids between clusters, all of it exists, silently shaping what you see. When you look into the dark, you're looking into the substance that makes the universe possible. Astronomers use the term dark halo to describe the invisible envelope of matter surrounding galaxies. These halos are enormous, far larger than the visible parts of the galaxies themselves. The stars and gas we can see make up only the central regions, a luminous core within a dark sphere. When galaxies collide, their halos interact too, merging and stretching into long filaments. The visible fireworks of star formation that follow, the bright bursts and tidal tails, are only the surface effects. The real dynamics happen in the invisible mass beneath, where gravity sculpts the encounter. In large-scale simulations of the universe, dark matter is the first ingredient. The models start with a nearly uniform field of particles, then let gravity do its work. Over billions of years, the dark matter collapses into filaments and clumps, forming the skeleton of the cosmic web. Normal matter, the atoms that form stars and galaxies, falls into these gravitational wells, collecting along the same structures. Without the dark, the light would have nowhere to gather. Every galaxy you see owes its existence to this invisible framework, and yet, despite its importance, dark matter remains theoretical. We can infer it, but we can't isolate it. We know how much of it there must be to explain observations, but we can't yet say what it is. It's a placeholder in our equations, a name for something real but ungraspable. Some scientists have proposed alternatives, modified theories of gravity that might explain the observed motions without invoking unseen mass. These ideas remain debated, but none has yet matched the predictive power of dark matter. For now, the simplest explanation remains that most of the universe is made of something we can't see. There's a quiet beauty in that humility. The galaxies that hide in the dark remind us that knowledge is always partial. We live surrounded by mysteries that we can describe but not define. The dark isn't a failure of science. It's a sign that the universe still has layers beyond our reach. Every photon of light we collect comes from a structure built on unseen foundations. Every image of a galaxy is a portrait of the visible half of a hidden whole. Even within the Milky Way, the influence of dark matter is profound. The stars in our galaxy's outer regions move faster than they should if only visible matter were present. Their orbits tell us that we're embedded in a massive halo of dark matter that extends far beyond the disk. The Sun itself moves through this halo, orbiting within the invisible mass. In a sense, we live inside a dark galaxy, though we perceive only its luminous centre. The night sky we see is just the tip of something much larger, a faint glow atop a vast unseen ocean of gravity. As telescopes become more sensitive, we're beginning to detect the faintest traces of galaxies that barely shine. Some are so diffuse that their stars are spread thin, giving off only a whisper of light. Others are veiled behind dust or hidden in the glare of brighter companions. These faint systems blur the line between visible and invisible, between the lighted and the dark. They remind us that the universe doesn't divide neatly into what we can see and what we can't. It's a continuum, a spectrum of brightness and shadow. The search for dark galaxies and dark matter is one of the frontiers of modern astronomy. Massive detectors deep underground wait for the rare collision between a dark particle and ordinary matter. Space missions look for subtle gravitational effects that could reveal new clues. Particle accelerators probe the smallest scales, searching for hints of forces beyond the standard model. Each effort is part of the same quest, to bring the unseen into understanding. There's a certain irony that the darkest parts of the universe may one day illuminate our greatest discoveries. If we can understand what dark matter is, we'll understand how galaxies formed, how structure emerged, and perhaps even why the universe looks the way it does. The galaxies that hide in the dark are not obstacles to discovery, they are the key to it. Their invisibility is not a void, but an invitation. It's easy to imagine the universe as a battle between light and dark, between what we know and what we don't. But the truth is softer. The light and the dark are partners, not opposites. The galaxies that shine exist because the dark holds them together. The dark gives form to the light. Without one, the other would be meaningless. The beauty of the universe lies not in its brightness alone, but in the balance between the seen and the unseen. When you look up at the sky, remember that what you see is only the surface. The true universe, the full, complete one, stretches far beyond sight. It's built from darkness as much as from light. The galaxies that hide there, silent and invisible, are as real as the ones that glow. They move through the same gravity, trace the same web, shape the same story. Their existence reminds us that the cosmos is always deeper than appearance, that even the darkest places are full of meaning. Somewhere out there, beyond the reach of light, entire galaxies drift unseen. Their stars are few, their glow faint, but their gravity is strong. They bind other galaxies, bend light, and whisper their presence through subtle motions. They are the hidden half of the universe, not lost, not gone, just waiting for instruments sensitive enough and minds patient enough to find them. And even if we never see them directly, their imprint will remain. The universe moves according to their pull. The galaxies that hide in the dark shape the ones that shine, just as the invisible shapes every part of the visible world. They are the quiet architects of everything that is. The universe does not change because we look at it, but somehow it always seems to grow each time we do. Every improvement in our instruments, every refinement in our methods, expands the boundaries of what we know, as if the act of seeing were also an act of creation. The galaxies, the stars, the great cosmic structures, they were always there, of course, patient and unbothered by our attention. But our awareness of them has evolved, stretching outward with every new telescope, every clearer image, every photon caught after its long, quiet journey through space. The universe grows with our eyes not because it needs us to exist, but because each act of observation brings more of it into focus, filling the dark with meaning. If you think about how far we've come, it's almost impossible not to feel a quiet sense of awe. Only a few centuries ago, the universe we could see fit comfortably within a single page of a star chart. The Milky Way was everything, and even that was only faintly understood. A few decades later, the telescope expanded that world into a neighbourhood of stars and nebulae. Then, within a lifetime, our field of view exploded into the realm of galaxies, clusters, and the observable universe, a sphere of existence stretching tens of billions of light years in every direction. The pattern is unmistakable. Each generation sees farther than the one before, and each discovery enlarges the universe not by distance, but by comprehension. The word observable hides a quiet humility. It doesn't mean that the universe stops beyond what we can see. It simply marks the edge of what light has had time to reach us since the beginning. That boundary changes as we observe it, not because the universe itself shifts, but because our tools improve. Each new telescope pulls the horizon closer, turning what was invisible yesterday into something we can study today. The universe, in a sense, waits for us to notice it, revealing itself layer by layer, patient as light itself. When the Hubble Space Telescope was launched, it gave us our first truly clear view of the cosmos beyond Earth's atmosphere. Before that, ground-based telescopes were limited by the distortion of air, the shimmer and turbulence that blur the stars. Hubble's sharp vision showed us that what looked like faint smudges were actually entire galaxies. It captured the deep field, the ultra-deep field, and the countless images that redefined what space means. Each photograph wasn't just a record, it was an expansion. Every time Hubble opened its shutter, the universe became a little larger in our minds. And then came the James Webb Space Telescope, a machine designed to see even further into the infrared part of the spectrum where light from the earliest galaxies now resides. Because the universe is expanding, that ancient light has been stretched, redshifted, beyond visible wavelengths, Webb can detect it, capturing the glow of galaxies that formed only a few 100 million years after the Big Bang. In those first images, astronomers saw something astonishing. The earliest galaxies were more numerous, more organised, and more massive than expected. The universe at its beginning was already filled with light. These discoveries challenged models of cosmic evolution. For decades, scientists had believed that galaxies took time to form, that they began as small, chaotic clusters and slowly merged into larger structures. But the Webb data suggested that massive galaxies existed far earlier than anyone predicted. It forced cosmologists to re-examine their theories, to ask whether something fundamental was missing from their equations. Perhaps the early universe was more efficient at forming stars than we thought. Perhaps dark matter played a stronger role. Perhaps our understanding of how light interacts with dust and gas needs refining. Whatever the explanation, one thing was clear. The universe was richer and faster to create structure than our imagination had allowed. Once again, it grew with our eyes. The same pattern has played out across centuries. Each time we build a better way to see, the universe changes shape. When Galileo aimed his small telescope toward Jupiter, he found moons orbiting it, proof that not everything revolved around Earth. When Edwin Hubble measured the distance to Andromeda, he discovered that our galaxy was one among billions. When radio telescopes scanned the sky, they found invisible structures, pulsars, quasars, radio galaxies, sources of energy that emitted no visible light at all. Each step outward revealed something unanticipated. Every instrument, no matter how advanced, seems to uncover surprises that rewrite what we thought we knew. The universe grows not by addition, but by transformation. This growth is not just about scale, it's also about depth. As our instruments improve, we see not only farther away but deeper into phenomena we already know. The Milky Way, once just a broad band of light across the sky, is now a mapped spiral with known arms, clusters, and a central black hole whose mass we've measured. The Sun, once just the brightest thing in the sky, is now a studied engine, its interior probed through oscillations and neutrinos. Even planets within our own solar system, long considered familiar, reveal new secrets under the gaze of improved instruments. Every time we look closer, the universe expands inward as well as outward. There's a kind of poetry in how our tools mirror our curiosity. Each generation builds devices to answer the questions of the last, and in doing so creates new questions for the next. The great observatories on Earth, like the Very Large Telescope in Chile, or the upcoming Extremely Large Telescope, use adaptive optics to counter the blur of the atmosphere, creating images sharper than Hubble's. Space-based observatories like Webb, or the future Nancy Grace Roman Telescope, will map billions of galaxies, tracing how structure evolved across time. Even gravitational wave detectors, like LIGO and Virgo, have opened new senses, listening to the vibrations of space itself. With each sense we add, the universe's story becomes more detailed, more dimensional. The light we collect is no longer just visible, it's multi-spectral, multi-messenger, a chorus of signals arriving from every direction. And yet, even with all this progress, our horizon remains finite. There is always a limit to what light can tell us. Beyond a certain distance, the light from galaxies is so stretched that it blends into the cosmic microwave background, the afterglow of the Big Bang itself. Beyond that, there's only darkness, not because nothing exists there, but because light hasn't had enough time to reach us. It's a quiet reminder that the universe isn't something we'll ever finish seeing. There will always be regions that remain beyond reach, waiting for the future. Perhaps not our future, but someone's. The beauty of this is that our not knowing is built into the structure of things. The universe grows with our eyes precisely because it cannot be fully seen. Its size is infinite in practice, if not in mathematics, because perception always trails behind reality. That gap, Between what exists and what we can see is where curiosity lives. It's the space that drives discovery, that makes science possible. If we could see everything, if there were no darkness left to explore, the universe would stop growing for us. It's the limits that make expansion meaningful. Sometimes, when astronomers look at the newest deep-field images, they describe them as unsettling. Not because they're frightening, but because they're too full. The number of galaxies, the density of the field, the faint smears of light stretching to the edge of detection, all of it feels overwhelming. It's a strange reversal of expectations. We point our telescopes into the dark expecting emptiness, and we find only more light. The void keeps filling itself. The silence keeps speaking. The more we see, the more we realize how little we've seen. It's a paradox that fuels everything, discovery leading not to answers, but to larger questions. This constant growth also changes how we think about ourselves. Once, humanity imagined itself at the center of creation. Then we learned we orbit the sun. Then that our sun is one among billions in the Milky Way. Then that the Milky Way is one among billions of galaxies. Each expansion of vision has humbled us, but it's also connected us more deeply to the cosmos. The farther we look, the more we see that the same rules apply everywhere. The same elements, the same forces, the same possibilities. In every direction, the universe repeats the patterns that made us. It's as if every act of seeing affirms that we belong to what we observe. When light from distant galaxies reaches us, it carries not just information but memory. Each photon is a relic, a survivor of unimaginable journeys. Some have travelled for over 13 billion years, crossing space that has expanded 1,000-fold in the meantime. To catch such a photon in a detector is to witness endurance. It's to hold in a moment the entire history of motion and distance. The universe grows with our eyes not only because we see more of it, but because we begin to sense its persistence, the quiet, patient way it continues, indifferent to time, yet always arriving. There's also a more subtle kind of growth happening, one that's internal. Each image, each discovery changes how we think, how we imagine, how we dream. The expansion of the observable universe mirrors the expansion of consciousness. Our instruments may extend our eyes, but it's the mind that learns to interpret what they see. When we look at a deep field full of galaxies, we're not just collecting light. We're building understanding. We're training our thoughts to move beyond the scale of daily life, to inhabit distances measured in billions of light years. That shift, from the local to the cosmic, is one of the most profound transformations of the human story. And it continues. Every discovery of a new kind of light, a new kind of signal, adds another layer to how the universe grows with us. When we detected gravitational waves for the first time, we weren't just confirming a century-old prediction of Einstein's theory. We were opening a new sense, one that lets us hear the vibrations of space itself. These ripples, created by the collision of black holes or neutron stars, travel through the cosmos at the speed of light. They carry no light at all, yet they tell us about events otherwise invisible. It's another way the universe grows, not through more stars or galaxies, but through new ways of knowing. Soon, other kinds of observatories will add to this expansion. Neutrino detectors buried deep in ice, telescopes that measure cosmic rays, instruments that watch for fast radio bursts. Each one opens a different window. The universe is not silent. It speaks in many languages, and with each new translation, our picture of it becomes richer. It's not that the cosmos becomes larger, in fact. It's that our awareness of its complexity keeps deepening, layer after layer, like a painting that reveals more detail the longer you look. Sometimes it's easy to forget how new all of this is. The light we collect today will still be travelling tomorrow, next year, 1,000 years from now. The universe doesn't hurry. It offers itself slowly, photon by photon, to anyone willing to wait, and we, in our brief lifetimes, do what we can to catch those signals, to assemble them into meaning. The telescopes we build now may show future generations galaxies we can't even imagine yet. They will see farther, and the universe will grow again. There's a quiet symmetry to all of this. The cosmos expands physically, space itself stretching with time. At the same moment, our awareness expands too, pushed outward by curiosity. The two growths mirror each other. One is cosmic, one is cognitive. Together they create the experience we call discovery. Each time we build a better eye, the universe reveals a new layer of itself. It's as if the cosmos has been waiting all along for us to learn how to see. When you think of it that way, it's not that the universe grows with our eyes. It's that our eyes finally grow into the universe. Our instruments extend our sight, our minds interpret the patterns, and the boundary between what is known and what is possible moves outward. The galaxies don't multiply because of us, but our understanding of them does. Each image, each survey, each piece of data adds to the tapestry, making it denser, more intricate, more alive. And even as we reach these new heights of vision, the process remains grounded in something profoundly human: curiosity. That's what drives it. The same impulse that made ancient astronomers chart the stars with the naked eye. We've built machines to do it better, but the instinct is unchanged. To look into the dark and wonder what's there, to ask if the light will reveal more, to keep watching, even when the night seems endless, so the universe grows and we grow with it, not by adding more matter or more light, but by deepening our ability to perceive. The galaxies were always there. The light was always on its way. We simply needed time. Time to build the tools, time to learn how to listen, time to realize that seeing is not the same as knowing, and knowing is never finished. The horizon keeps moving, the universe keeps unfolding, and every time we open our eyes a little wider, it opens with us. When you look at the universe on its larger scales, a pattern begins to appear. It's not the kind of pattern that's visible to the naked eye, or even one that could ever be seen from any single point in space. It emerges only through patient mapping, through the long work of counting galaxies, measuring their positions, and connecting the dots across billions of light years. When you step back far enough, the galaxies stop appearing as isolated points and start forming structures, immense and interconnected. This is the cosmic web, the grand architecture of the universe, a vast network of filaments and clusters and voids, stretching in every direction as far as a light can reach. The name web isn't poetic exaggeration, it's descriptive. Galaxies are not distributed evenly across the cosmos. They gather along threads of matter that weave together into nodes, forming clusters where many galaxies reside, connected by filaments that can span hundreds of millions of light years. Between these filaments lie enormous voids, regions of space almost completely empty, vast expanses where there are few, if any, galaxies at all. The result is a pattern that looks, in simulation, like a three-dimensional web glowing softly in the dark. If you could see it in its entirety, it would resemble a neural network, or the branching of veins in a leaf, or perhaps even the filaments of light inside a brain. This web is not made of galaxies alone. The luminous parts, the stars, the gas, the bright clusters, are only the visible traces of something deeper. Beneath them lies the invisible scaffolding of dark matter. It's this hidden substance that shapes the web's structure. Gravity pulls the dark matter into filaments, and ordinary matter follows, drawn into the same paths. Where the filaments intersect, the pull of gravity is strongest, and there galaxies and clusters form. Light, in other words, follows the dark. The universe builds itself along these invisible lines, tracing out a geometry set by forces we can't see directly. The cosmic web is the product of billions of years of evolution. In the beginning, the universe was almost perfectly smooth, a faint glow of matter and radiation spread evenly in all directions. But even then, there were tiny fluctuations, small differences in density. Those differences, no larger than 1 part in 100,000, grew over time under the influence of gravity. Denser regions attracted more matter, becoming denser still, while emptier regions grew emptier. Over billions of years, those small variations stretched and amplified, forming the first filaments, the first clusters, the first galaxies. The web we see today is the result of that slow amplification, the fingerprint of gravity acting on the primordial universe. When cosmologists simulate the formation of the universe, they start with a field of random fluctuations and let gravity do its work. The results are astonishingly accurate. The simulations produce filaments and voids that match what we observe. The distribution of galaxies, their clustering, even their motion all fit the pattern. The same structure appears across scales, from small galaxy groups to vast superclusters. This self-similarity, known as a fractal-like property, gives the universe a coherence that transcends scale. The pattern repeats, not exactly, but rhythmically, as if the cosmos were built from variations on a theme. The filaments themselves are colossal. Some stretch for hundreds of millions of light years, containing thousands of galaxies strung like beads on a thread. The largest known structures in the universe, such as the Hercules Corona Borealis Great Wall, extend over 10 billion light-years, nearly a tenth of the observable cosmos. It's almost incomprehensible to imagine something that large, something that vast and continuous. And yet, when we map it, the structure is clear. The galaxies are not randomly scattered. They belong to this pattern, connected by forces that operate over unimaginable distances. Between the filaments lie the voids, vast, dark regions where very little exists. These voids are not truly empty, but their density is far lower than average. They make up most of the volume of the universe, while the filaments and clusters contain most of its mass. If you could somehow drift into one of these voids, you would find yourself in a region of space where galaxies are distant and rare, where the nearest cluster might lie hundreds of millions of light-years away. The darkness there would be almost perfect. Yet even in these emptiest places, faint traces of matter remain. A thin gas, a few drifting galaxies, perhaps a thread of dark matter passing unseen. The web is continuous, even where it looks like nothing. The cosmic web is more than a pattern of matter. It's a record of how the universe has evolved. The filaments trace the flow of material from the early universe to the present. Galaxies move along them, drawn toward the clusters at their intersections. Over billions of years, the web slowly changes shape. Filaments merge, clusters grow more massive, voids expand. Gravity continues to sculpt the pattern, though the expansion of the universe stretches it at the same time. There's a balance between two opposing forces, gravity pulling matter together and cosmic expansion pulling it apart. The web exists in that balance, frozen in motion, slowly evolving but never collapsing completely. It's easy to think of the universe as static when you look at the night sky. The stars seem fixed, the constellations unchanging. But on cosmic timescales, everything moves. The galaxies are drifting along the filaments, like leaves carried on a slow river. Clusters merge in slow-motion collisions, sending shockwaves through the intergalactic gas. Over tens of billions of years, the web itself will stretch further, the filaments thinning as dark energy drives the expansion of space. One day, distant galaxies will slip beyond our horizon, their light redshifted until it fades from view. The cosmic web will remain, but our part of it will grow lonelier. To understand this structure, astronomers use vast surveys, projects that map millions of galaxies in 3 dimensions. One of the most famous is the Sloan Digital Sky Survey, which has created maps of the universe that span billions of light-years. When you plot the data, the pattern leaps into view, dense knots where clusters form, long filaments connecting them, and dark voids between. The structure is unmistakable. The web looks alive, like something organic, a frozen moment of motion. It's strange to realise that these maps are not of a static object but of a process, a cosmic dance unfolding over eons. The filaments are not empty lines, they're filled with gas and dark matter, the raw material for future galaxies. Observations using X-ray and radio telescopes have begun to detect the faint glow of this intergalactic medium, heated by the passage of shock waves as galaxies and clusters interact. The temperature of this gas can reach millions of degrees, though its density is incredibly low, a few atoms per cubic meter. It's the universe's connective tissue, thin and nearly invisible but essential. Without it, galaxies would be isolated islands. With it, they are part of a grand continuum, exchanging matter and energy across scales we can hardly imagine. Our own galaxy, the Milky Way, sits within this web, a small node in a larger structure called the Laniakea supercluster. The name, from Hawaiian, means immense heaven. It's fitting. Laniakea encompasses over 100,000 galaxies, stretching 500 million light-years across. Within it, the Milky Way belongs to a smaller group of galaxies, the Local Group, which includes Andromeda and a few dozen smaller companions. These, in turn, are connected to the Virgo cluster and other nearby clusters, all bound together by gravity into one continuous flow. The cosmic web, when seen this way, is not just a map of distant space, it's our address. Understanding the shape of this web is one of the central goals of modern cosmology. It tells us not only how the universe is arranged, but how it came to be. The size and distribution of the filaments depend on the amount of dark matter, the properties of dark energy, and the physics of the early universe. By studying the web's geometry, we can test theories of cosmological evolution. We can measure how fast the universe expands, how structure grows, and even how the invisible components of reality behave. The web is not just a pattern, it's a key. It holds the answers to questions about the universe's past and future. The way the web looks today reflects billions of years of competition between gravity and expansion. Early in the universe's history, matter dominated. Gravity pulled everything inward, forming structures rapidly. But as dark energy began to influence the cosmic balance, the expansion accelerated. The growth of new structures slowed. The web we see now is the result of that tension, dense regions growing denser, while the spaces between them stretch wider. It's a dynamic equilibrium, always shifting but always following the same fundamental rules. To see the web as it truly is, we have to combine data from many sources. Optical surveys show us the positions of galaxies. Radio and X-ray observations reveal the hot gas that fills the filaments. Gravitational lensing maps the invisible dark matter. Together, they form a composite picture, one that's still incomplete, but growing sharper every year. Supercomputers simulate the evolution of the web, tracing how it might look billions of years in the future. The agreement between simulation and observation is remarkable. It tells us that, for all our uncertainty, we've captured something essential about how the universe builds itself. When you think about the cosmic web, it's tempting to wonder why it looks the way it does. Why this pattern and not another? The answer lies in the physics of gravity and motion. Small fluctuations grow into large structures because gravity acts universally, pulling matter together wherever it's slightly denser. The same process repeats across scales, creating a self-organizing pattern that's neither random nor perfectly regular. It's the natural outcome of simple laws applied over vast distances and times. The result is a universe that looks both chaotic and ordered, a complexity born from simplicity. There's something quietly humbling in the realization that the universe's largest structures mirror the shapes we find in nature on smaller scales. The branching of trees, the veins in a leaf, the filaments in a brain, all follow similar mathematical principles. Patterns of connectivity, efficiency, and balance recur across magnitudes. The cosmos, in its enormity, seems to echo the same logic that governs life. It's not that one causes the other, but that both arise from the same underlying mathematics of growth and connection. The web of galaxies and the web of neurons are cousins in form, different in content but similar in essence. And though we can't step back and see the whole structure with our own eyes, the maps we've built give us a sense of it. The cosmic web is not a single thing in space. It's a pattern that exists everywhere at once, woven through the universe like a hidden fabric. You are part of it. The atoms in your body trace their origin back to stars that formed along its filaments. The gravity that holds your feet to the ground is the same gravity that shaped its curves. The web is not out there. It's the structure of everything, including you. As we continue to study it, the web will keep revealing new details. We'll measure its temperature, its density, its subtle vibrations. We'll map how galaxies move along its threads, how clusters merge at its intersections. We'll learn how the invisible dark matter flows, guiding the visible light. And each new discovery will remind us that the universe is not a collection of separate things, but a connected whole. The filaments are the lines of that connection, the threads that tie existence together. The shape of the cosmic web is, in the end, a reflection of the universe's nature. Structured yet open, vast yet cohesive, always evolving. It's a reminder that what seems empty is full, that what seems separate is joined, that the darkness between galaxies is not absence but structure. The web stretches through everything, unseen but undeniable, binding light to dark, matter to gravity, and us to the rest of the cosmos. The night sky looks eternal. The stars, the galaxies, the faint clouds of light, they seem fixed, endless, beyond the touch of time. But nothing in the universe lasts forever, not even the light that fills it. Every star that burns, every galaxy that shines, is moving toward an end. Some will fade quietly, others will end in bursts of brilliance. Over long enough timescales, even the universe itself will grow dim. It's not a tragedy, though it sounds like one. It's simply the way things change when time is given room to stretch beyond imagination. The universe has a beginning, and someday it will have an ending. Not a sudden one, but a gradual dimming, a slow descent into quiet. When you look at the Milky Way on a clear night, you're seeing a moment frozen in cosmic time. The stars are still forming, the spiral arms still bright with young clusters, but that activity is already slowing. The gas that fuels new stars is being used up little by little. Over billions of years, the rate of star formation in our galaxy will decline. The brilliant blue stars that light the spiral arms will burn out quickly, leaving behind redder, cooler suns that glow more softly. Eventually, the night sky will fade as those last young stars die, and no new ones replace them. The galaxy will still exist, but its light will thin, its colour redden, its edges dim. The same will happen everywhere. The end of light doesn't come all at once. It unfolds in stages, each lasting billions or trillions of years. The first stage is the fading of the bright, short-lived stars. These massive suns burn through their fuel quickly, living fast and dying young. They end their lives in supernova explosions, scattering elements into space and leaving behind neutron stars or black holes. Their deaths seed the next generation of stars, recycling matter again and again. But as the supply of gas runs out, that cycle slows. Galaxies that were once filled with star-forming regions become quiet. The spiral arms lose their definition. The universe's colour palette shifts from blue and white to yellow and red. The cosmos grows older in tone. In the far future, perhaps 100 trillion years from now, the last stars will form. They'll be small, cool, and dim, red dwarfs that burn their fuel slowly over immense spans of time. These faint suns can live for trillions of years, glowing quietly while the rest of the universe fades around them. When they finally exhaust their hydrogen, they'll become white dwarfs, hot, dense remnants that shine only with residual heat. Slowly, even that heat will dissipate. The white dwarfs will cool into black dwarfs. Cold, dark spheres drifting in silence. The galaxies will still exist, but they'll be invisible. The universe will have entered what physicists call the degenerate era, when all remaining light comes from the slow decay of dying matter. Before that distant age, though, there will be a long period of transformation. Galaxies will continue to collide and merge, their stars pulled into new arrangements. The Milky Way and Andromeda, for example, are already on course to merge in about 4 billion years. The collision won't be a violent crash as we imagine it. The stars themselves are so far apart that few will ever collide directly. Instead, the galaxies will pass through each other, their shapes distorted by gravity, their gas clouds compressing to form new bursts of stars. Over time, the two spirals will merge into a single, larger elliptical galaxy, quieter, redder, older. This process is not unique. It's happening everywhere. The universe is constantly reshaping itself, even as its light slowly declines. On an even larger scale, the clusters and filaments of the cosmic web will continue to evolve. Gravity will pull galaxies together into ever larger structures, while dark energy, the mysterious force driving the acceleration of cosmic expansion, pushes them apart. Eventually, dark energy will win. The expansion will outpace gravity's ability to bind new structures. The web will thin. Clusters will grow isolated, drifting away from one another. The observable universe will become a patchwork of island galaxies, each one surrounded by darkness, its nearest neighbours receding beyond sight. The universe will appear to empty, though nothing has vanished. The light will still exist, but stretched by expansion, redshifted into wavelengths so long they'll fade beyond detection. At that point, the night sky of any surviving civilization would look very different from ours. The great galaxies that fill our telescopes now would no longer be visible. The cosmic microwave background, the faint afterglow of the Big Bang, would have stretched so much that it would no longer be detectable. To those distant observers, the universe would seem static, cold, and nearly empty. The evidence of its own beginning would have vanished beyond reach. For them, cosmology as we know it would be impossible. The story of expansion, of galaxies, of light itself would be hidden in the past like a memory erased by time. But even then, the universe wouldn't be over. It would simply be changing phase. The stars would continue to evolve one by one. Black holes would dominate the centres of galaxies, swallowing what remains of the gas and dust. Some might even merge, forming larger and larger black holes. These cosmic giants would be the last luminous objects in the far future, shining faintly in X-rays as they consume stray matter. Around them, the remnants of stars, as white dwarfs, neutron stars and planets, would orbit in silence. Eventually, even those orbits might decay, as gravitational interactions and black hole mergers rearrange what remains. Over unimaginably long timescales, even black holes will fade. According to quantum physics, they are not perfectly black. They emit a faint radiation, now known as Hawking radiation, caused by quantum effects near the event horizon. This radiation is incredibly weak, undetectable for black holes of ordinary size, but over trillions upon trillions of years, it adds up. Slowly, black holes will lose mass, shrinking and eventually evaporating entirely. The largest supermassive black holes, those millions or billions of times the mass of the Sun, will be the last to go, their final photons released after a time so vast it defies language. After that, there will be no stars, no galaxies, no light, only cold particles drifting in an expanding void. This is the universe's long future, known as the heat death, a time when energy is evenly distributed, when no more work can be done, when everything that can happen has already happened. It sounds bleak, but it's not really an ending. It's a state of rest, a balance reached after endless transformation. The same physics that gave rise to stars and life will eventually bring everything to equilibrium. Entropy increases, as it always has. The lights go out, but the universe remains. It's strange to imagine such a future when everything familiar has faded away. Yet even now we're living in a universe that's already halfway through its story. The first stars formed more than 13 billion years ago, and the peak of star formation happened about 10 billion years ago. Since then, the rate has been declining. The cosmos is no longer young, but it's still full of light and will be for billions of years to come. The galaxies still glow, the stars still shine, and the night sky, for all it's quiet, is still alive. We exist in a luminous age, a brief window of brilliance between the universe's hot beginning and its cold future. Some scientists have wondered if that future might hold surprises. Perhaps dark energy will change over time, altering the universe's fate. Perhaps new physics will emerge, allowing new structures to form even after the stars fade. There are theories that suggest quantum fluctuations could create new universes, tiny bubbles of space-time that expand to become entire cosmoses of their own. In that sense, the death of this universe might be only the birth of another. The lights go out here, but they might turn on elsewhere. The cosmos could be an endless cycle of creation and dissolution, each universe seeding the next. Still, from where we stand, the idea of darkness is powerful. Light has always been our way of knowing. The galaxies we see, the stars we navigate by, the data we collect. All of it depends on light. When we imagine a universe without it, we imagine a universe without witness. But that's only our perspective. The universe doesn't need light to exist. It simply is. The end of shining things doesn't mean the end of being. It just means a change in what being looks like. Even in that distant future when the last photons fade into the background, something of light will remain. The information carried by every particle, every interaction, every wave, all of it will still exist, dispersed but not destroyed. The universe will have written its story, encoded in the distribution of energy and matter, and while no one will be there to read it, it will still be there, imprinted in the fabric of space-time itself. The lights will go out, but the memory of light will never vanish completely. It's difficult to think about such vast timescales. Trillions upon trillions of years, numbers so large they outstrip imagination. But perhaps that's the point. The universe invites us to stretch our sense of time, to see existence not as something fleeting but as something continuous. Our own lives are short flashes of awareness, but they happen within a story that spans eternity. When we look up at the stars tonight, we're seeing the middle chapter of that story, the luminous part, the moment when the universe is at its brightest. We're part of the light before it fades, and there's a quiet comfort in knowing that. The same processes that will one day dim the stars also made them shine in the first place. The same physics that will cool the galaxies also built them. The universe isn't moving toward an ending in any moral sense. It's completing a cycle. The heat will fade, but the balance will hold. The cosmos will rest. When the lights go out, the night will not be empty. It will be full of the traces of everything that ever was. The atoms forged in stars, the gravity that shaped galaxies, the photons that once illuminated the dark. Even in silence, those traces will endure. The universe doesn't vanish when it grows quiet. It simply changes form. And perhaps somewhere in that infinite quiet, the seeds of new light will gather again, waiting for another beginning. The lights go out slowly, so slowly that we'll never notice it happening. The stars will keep burning, the galaxies will keep turning, and life, in whatever form it takes, will go on for eons. But the direction is clear. The universe is cooling, expanding, settling into stillness. The same way a fire burns bright before fading to embers, the cosmos glows now before resting. And we, for a brief moment, are here to witness it, beings made of light, watching light itself. If you could stand outside time and watch it all unfold, from the first stars to the last, you would see the universe like a single breath, a rise, a pause, a slow exhale into stillness. It would begin in a flash and end in calm. and somewhere within that breath we would appear, look up and see the glow, and wonder what it means. The lights would shine for us, and then, long after we're gone, they would keep shining for others, until finally they fade. But even that fading carries its own kind of beauty. The universe's long twilight isn't a failure or a loss. It's the natural outcome of energy finding balance, of time doing what it does best, moving forward. The lights will go out, yes, but before they do, they will have illuminated everything. The galaxies, the planets, the atoms, the minds capable of knowing them, and that illumination, that moment of awareness will have been enough. It's hard to imagine something as vast as the universe fitting inside something as small as a human thought. Yet, in a way, it does. Everything we know about galaxies, stars, time and space exists as patterns of understanding inside our minds. The universe, with all its scale and age and complexity, is too large to experience directly. We can't walk across it, can't stand outside it to see its shape. All we can do is think about it. We hold it in our awareness, in fragments of light and logic, like a reflection in a still pool. It's strange to realize that this infinite thing, this structure of uncountable galaxies, can be contemplated by a brain that fits inside a skull. It's stranger still that the universe built the very minds that now imagine it. Every atom in your body was forged in stars. The iron in your blood came from supernovae, the calcium in your bones from ancient stellar cores, the carbon and oxygen from long-dead suns that burned before Earth even existed. When you look up at the sky, you're looking at the source of yourself. The galaxies out there are not distant in kind. They're distant in space, but not in nature. You're made of the same materials, arranged differently, following the same laws. You're a small expression of a large pattern. The universe doesn't just surround you, it continues through you. It's easy to forget this connection because we live on human scales. Our lives unfold in years, our days in hours, our movements across distances we can walk. The universe moves in billions of years, across distances that light takes eons to cross. The mismatch between those scales can make it feel like we live in a separate world, one of human time and ordinary experience apart from the cosmic one. But they're not separate at all. The small reflects the large. The curvature of a teacup follows the same geometry that governs planets and orbits. The steam rising from its surface follows the same thermodynamic laws that drive the motion of galaxies. The entire cosmos is encoded in the details of the world around you, if you know how to look. When you pour tea and watch the surface ripple, you're watching gravity and motion at work. The way the liquid settles into stillness mirrors the way matter finds equilibrium in space. The swirl of the steam above it echoes the turbulence of gas clouds forming stars. The warmth that fades into the air is the same principle that drives entropy across the universe. Energy spreading evenly, seeking balance. These parallels aren't metaphors, they're real continuities. The same physics governs both, scaled by size and time. A cup of tea cools in minutes, a galaxy cools in billions of years. The principle is the same. This is why scientists often say that to understand the universe, you don't always have to look outward. Sometimes it's enough to look closely. The universe isn't only a place. It's a set of laws, of relationships, of patterns that repeat endlessly across scale. When you hold an object, you're holding the product of those same relationships. Atoms arranged according to the rules of electromagnetism, molecules bound by the exchange of energy, matter organized by forces that have operated since the first seconds after the Big Bang. The universe is not distant, it's intimate. It's in your hands, in your breath, in every heartbeat that depends on starlight filtered through time. That realization changes what it means to study the cosmos. It's not about separating ourselves from it, not about gazing from a distance. It's about recognizing that the act of observing is itself part of the system. When we point a telescope toward a galaxy, we are the universe looking back at itself. The light that enters the lens began in the heart of a star billions of years ago, travelled across expanding space, and ended its journey inside a human instrument built by beings who evolved from that same cosmic material. The circle completes itself. The observer and the observed are made of the same thing. When you think of it that way, the phrase, "a universe in a teacup," doesn't sound like exaggeration. It's a reminder that the cosmos is not something far away and unreachable. It's here, condensed into the familiar. Every small detail of existence holds within it the rules of the whole. The ripples in your drink, the glow of a candle, the movement of air through a window, all are governed by the same laws that shape galaxies and stars. The scale changes, but the truth does not. The universe is fractal in its logic. It repeats itself in different sizes, different forms, but always with the same underlying order. There's something calming about that. The vastness that once felt intimidating becomes close, almost domestic. The same universe that stretches across billions of light years is also the one that allows you to exist at all. The cosmic and the personal are not two separate realities. They are one continuous story, unfolding at different magnitudes. When you breathe, you're participating in cosmic chemistry. When you think, you're engaging in the organization of matter into consciousness. The universe expresses itself in galaxies, but it also expresses itself in you. The idea that the cosmos lives within awareness isn't a poetic claim. It's a physical truth. The information of the universe, the structure of its laws, the shape of its history, is stored and represented in the brain as patterns of electrical activity. When you imagine the Milky Way, or recall an image from the Hubble Deep Field, that image exists as neurons firing in specific sequences, creating a model of the cosmos within the mind. You are, in a literal sense, holding galaxies in your head, not their physical matter, but their meaning. The same light that travelled billions of years to reach Earth is converted into thought, into memory, into understanding. The universe becomes self-aware through that process. This doesn't mean the cosmos has consciousness in any intentional way, but it does mean that consciousness is one of its natural outcomes. Matter, under the right conditions, organises itself into forms capable of reflecting on their own origins. When you sit quietly and think about galaxies, you're part of that reflection. You're one of the ways the universe examines its own structure. The light that began as radiation from the early universe now exists as comprehension, as insight. The transformation is continuous. Energy becomes matter. Matter becomes life. Life becomes thought. The teacup holds the universe not because it contains its mass, but because it participates in its logic. If you trace that logic backward, you find that everything around you, from the steam curling upward to the stars far beyond, shares a single origin. All of it began as a dense, hot state of energy, expanding and cooling, forming particles, atoms, molecules, stars, and eventually the elements that would become your body. The atoms in your hands are ancient, older than the solar system. Some come from long-dead stars that exploded before Earth formed. Some may have been part of the same gas clouds that built the Milky Way. Each one carries a record of cosmic history, a story written in its composition. When you touch anything, you're touching the oldest things there are. It's almost impossible to feel that scale directly, but it's comforting to know that it's true. The boundaries between self and universe blur when seen in this way. The energy that keeps you alive is sunlight. Photons released from nuclear reactions in the sun, travelling through space for 8 minutes before striking your skin. That light is what powers the food you eat, the air you breathe, the warmth you feel. Without it, life would cease. The same nuclear processes that light the stars also sustain every heartbeat. You are literally fueled by starlight. The galaxies out there are not separate from you. They're your energy's ancestors. There's a quiet symmetry in realizing that the act of thought, of understanding the cosmos, is itself powered by the cosmos. Every neuron that fires in curiosity, every calculation or observation runs on energy that came from distant stars. You are, in a physical sense, made of the very light you seek to understand. The circle closes again. The universe reflects on itself through you, and you in turn find meaning in that reflection. When scientists build models of the cosmos, they condense billions of light years into equations, into simulations that can fit on a screen. These digital universes behave according to the same physics as the real one. They evolve, form filaments, birth galaxies, expand. Within those models, the same patterns appear, the same structures we observe in reality. In those moments, the universe is truly held within something small. A supercomputer becomes a microcosm of creation. The same can happen in thought. A single mind with limited senses and finite time can hold the logic of infinity. It's not the size that matters, it's the coherence. The universe fits in a teacup because its laws are simple enough to be understood, yet rich enough to contain everything. The concept of scale often tricks us. We think that large means important, and small means insignificant. But the cosmos doesn't seem to follow that rule. Every scale is equally essential. The nucleus of an atom obeys the same quantum principles that determine the fusion in stars. The curvature of space-time that bends galaxies also governs the fall of a pebble. The complexity of life arises from interactions at microscopic levels, which mirror the interactions of matter at cosmic levels. The universe is not a hierarchy, but a continuum. Every part reflects every other. Even the act of drinking tea can serve as a meditation on this. The heat moves from the cup to your hands, from your hands to the air, from the air outward in endless diffusion. Nothing is lost, only transformed. Energy flows, balances, and dissipates, just as it does in stars and galaxies in the expansion of space itself. The calm that comes from noticing this isn't philosophical abstraction, it's recognition. You're participating in the same physics as everything else. The motion of heat, the pull of gravity, the play of light, all of it connects. When you sit quietly and think about galaxies, you're bridging immense distances without moving. The light that travelled billions of years now completes its journey in your mind. You're uniting scales that otherwise never meet, the infinite and the intimate, the cosmic and the human. That connection is what makes the study of the universe so deeply personal. It's not about escaping Earth to look outward. It's about realizing that the outward and inward are one continuous field of existence. The universe doesn't just fill the sky, it fills the mind that looks at the sky. This realization doesn't make the universe smaller, it makes experience larger. Knowing that your body, your thoughts and your world are part of the same system that created the galaxies dissolves the sense of separation. The stars aren't distant anymore. They're part of your history, part of your matter, part of your moment. The vastness that once seemed remote becomes a kind of closeness. The universe doesn't live beyond reach. It's here, now, waiting to be noticed. And in that noticing, something profound happens. The act of awareness creates connection. The observer becomes part of the observed. The cosmos, in its entirety, finds a home in a finite mind. That's what it means to hold a universe in a teacup, to recognize that the same forces that shape galaxies also shape your thoughts, and that through understanding, you become part of the universe's self-portrait. You can feel that connection in quiet moments, when everything slows and you sense how much of the world moves through you. Air, light, warmth, gravity. The simplicity of that awareness is enough to make the scale of the universe feel less intimidating. You don't have to hold all of it at once. You only have to remember that it's already within you. Every breath, every heartbeat, every flicker of thought is a continuation of cosmic history. The stars made the atoms made you. The you that looks back at the stars closes the loop. The universe fits inside you not because you contain its space, but because you share its structure. It's the same story written in smaller letters, the same principles expressed in a more intimate form, The galaxies, the tea, the light, the thought, all are parts of the same pattern. The cup and the cosmos are made of the same matter following the same laws. The difference is only in scale, never in essence. And so, the next time you hold something small, a teacup, a pebble, a handful of air, remember that you're holding the universe too. You're holding a piece of everything that ever was and everything that will be. The cosmos may stretch beyond measure, but it also fits perfectly in your grasp, because the act of grasping, of understanding, is what makes it whole. The night is still, and the sky above looks almost unchanged from how it must have looked to people thousands of years ago. The same faint shimmer of stars, the same slow arc of the Milky Way across the horizon, the same distant, quiet light arriving from galaxies that have been shining since long before there were eyes to see them. When you lie beneath that sky, there's a strange sense of both distance and closeness. The stars seem impossibly far away, yet their light is right here, touching you, entering your eyes, becoming part of your awareness. It's one of the simplest and oldest connections in existence, the meeting of light and mind, of the universe and the small piece of it that knows it exists. The idea that the sky we see is shared by everyone who has ever lived can be easy to forget. The same photons that land on your skin tonight are the same kind that fell on ancient astronomers, on travellers who crossed oceans by starlight, on early humans who didn't yet have words for what they were seeing but still felt wonder when they looked up. The stars have been the background of every story, the silent witnesses of everything that has ever happened on this planet. No matter what has changed, the sky has remained. It's not ours alone, but it feels personal, a private canvas for every thought that drifts upward. Some nights, it's easy to imagine that the universe is quiet, that beyond the faint light there's only stillness, a great expanse of calm. But even now, that calm is full of motion. Galaxies are spinning, stars are forming and dying, planets are turning in their orbits. Light is moving across trillions of miles to arrive here. The universe never stops. It breathes in cycles too slow for us to notice. Rhythms measured not in seconds, but in billions of years. Everything that seems still is moving, and everything that seems separate is connected. Under the same sky, you and I exist in that motion. The atoms in your body, the air you breathe, the warmth on your skin, all of it part of that same ongoing exchange of energy that began with the first light. It's easy to forget that connection in the noise of daily life, when the universe feels distant and abstract. But when the night is quiet and the air is still, you can feel it again. The earth turning, carrying you gently through space. The faint pull of gravity holding you in place while the planet spins. The light from distant stars, billions of years old, arriving now, completing a journey that began long before your existence. You don't have to reach for meaning in that. The meaning is already there, in the fact that it happens at all. The universe is vast beyond comprehension, yet it follows rules that can be understood. It creates complexity out of simplicity, structure out of chaos, light out of darkness. You are one of those structures. Your thoughts are one of those patterns. The same laws that shaped galaxies also shape the folds of your brain. The same balance that governs the motion of stars governs the movement of your heartbeat. The universe doesn't stop at the edge of space. It continues here, inside you, as awareness. When we talk about billions of galaxies, about the web of matter stretching across the cosmos, it's easy to get lost in the numbers. But what those numbers really mean is that the universe has had time and space enough to make almost anything possible. Somewhere, light is always being born. Somewhere, matter is cooling and collecting into new forms. Somewhere, a planet circles a star and reflects its light across space. The process is continuous. Even as old stars fade, new ones emerge. Even as light travels outward, new light begins. The universe doesn't end, it changes. That continuity is what the sky shows us. The stars you see tonight are not all the same age or distance. Some are young and bright. Others are ancient, their light older than the species observing it. Some have already died, and their light is only now reaching you, a message from a past that no longer exists. Yet together, they create a single image, a field of light that seems constant and eternal. The sky is a time machine, a layered map of moments overlapping. Every point of light is a different chapter of the same story. You're seeing the universe as it was, not as it is, but it doesn't matter. What matters is that you can see it at all. To understand the cosmos is to realize that time and distance are not barriers but connections. The light that began its journey billions of years ago is the same light that now falls across your face. You're linked to the distant past, to events so far away they no longer exist except through their light. That connection is real, physical, measurable. It's the thread that ties the smallest life to the largest structure. Under the same endless sky, you are part of that thread. And perhaps that's what draws us to the night again and again. Not the need to understand, though understanding is part of it, but the quiet recognition that the universe is both beyond us and within us. We look up because something in us remembers. The atoms in our bodies remember. The light that built us once belonged to stars, and it carries that memory still. Looking at the sky is, in a way, looking back at ourselves, not in the sense of identity, but in the sense of origin. The light returns home, completing its path through awareness. The more we learn about the universe, the more that sense of connection deepens. We used to think the stars were holes in a black dome, then distant suns, then parts of galaxies, then parts of a universe without centre or edge. Each discovery made the cosmos larger, but it also made our place in it clearer. We're not at the centre, but we're not outside it either. We're woven into it, the way threads are woven into fabric. Every thought we have, every discovery we make adds another stitch to that fabric. The universe learning about itself through us. It's easy to think that the universe is indifferent, that it simply exists without care. But even indifference can contain beauty. The laws that govern everything don't need intention to create harmony. Gravity doesn't decide to form stars. Chemistry doesn't choose to make life. Yet it happens, and it happens everywhere conditions allow. The result is a cosmos that balances order and chaos, simplicity and complexity, expansion and stillness. The same balance that allows galaxies to form also allows life to think about galaxies. That's not accident, it's continuity. When you sit quietly beneath the stars, you become part of that continuity. The photons that reach you tonight may have left their sources before the Earth even existed. Some may have passed through clouds of dust, through the gravitational fields of other galaxies, through billions of years of expanding space, only to land here, on your eyes, in this exact moment. The odds of that are beyond comprehension. Yet it happens constantly, every second, everywhere. The universe is always arriving. It's a strange thought, that every point in space is the centre of its own observable universe. Wherever you are, you can look outward and see roughly the same horizon of light, the same vastness stretching in every direction. There is no single centre, no privileged viewpoint. The cosmos looks the same from every location because it has no edge. Every observer, every planet, every galaxy occupies its own centre. You are the centre of what you can see, just as every other being is. The infinite doesn't need a single middle. It exists equally everywhere. Under the same endless sky, the differences between near and far begin to fade. The light that left a galaxy billions of years ago is the same kind of light that glows from your campfire or reflects off water. The physics is identical, the scale changes, but the principle holds. Light moves, heat diffuses, matter forms and transforms. The same story plays out across every level. You could live a lifetime studying it, and still only grasp a fragment. But that fragment is enough. To see even a sliver of the universe clearly is to glimpse the whole. There's a quiet humility that comes with that understanding. We are small, yes, but not insignificant. We are the universe made small enough to notice itself, long enough to ask questions, bright enough to see. The galaxies do not need us to exist, but without beings like us, there would be no one to marvel at them, no one to turn photons into meaning. Awareness doesn't add to the universe's mass or energy, but it adds something intangible, reflection, the ability to recognize beauty, to name it, to share it. The cosmos is beautiful in itself, but it becomes something more when it is seen. If you look long enough, the night starts to change. The stars seem to shift, the constellations move as the Earth turns, and the faint light near the horizon grows brighter. Morning begins quietly, as it always has. The stars fade one by one, not because they stop shining, but because the light here grows stronger. The same photons that travelled billions of years now vanish behind the ones made in our own sky. The transition is seamless, the light of the universe giving way to the light of the sun, both part of the same continuum. You can take comfort in that repetition. The night will come again, and the stars will return. The universe doesn't vanish when you can't see it. It's always there, patient, waiting for darkness to fall again. The rhythm of day and night is a reminder that everything moves in cycles. Stars are born, shine, and die. Light travels, fades, and returns in new forms. Even we move through those cycles, brief but part of the same pattern. Nothing is lost, only changed. And when you look up the next time, you'll see it differently. Not as a distant, unreachable expanse, but as something continuous with you. The galaxies are not out there. They're part of the same story you live in. The air you breathe, the ground beneath you, the atoms that make your body, all of them are threads of that same cosmic fabric. You exist under the same endless sky as every star, every galaxy, every being that has ever looked up and wondered. So as you listen to the quiet now, think of that connection. Think of the light still travelling, the galaxy still turning, the universe still unfolding. You don't have to hold it all in your mind. You only have to remember that it includes you. The same gravity that shapes galaxies holds you to the Earth. The same light that fills the cosmos warms your skin. The same time that measures the age of stars measures your heartbeat. Everything is part of the same continuum. The night sky will always remind you of that, not by speaking, not by answering, but by being. Its silence isn't emptiness, it's fullness. The light you see is the universe saying in its own way that it's still here, still growing, still connected. You don't have to reach the stars to belong to them, you already do. Thank you for drifting through the cosmos with me tonight, and for letting your mind wander across light years of time and space. If you found some calm in these thoughts, if the slow rhythm of galaxies and gravity has helped you breathe a little easier, you can stay a while longer. The universe isn't in a hurry, and neither are we. You're under the same sky as every star we've spoken about. The same one that glowed for ancient eyes, the same one that will glow long after we're gone. It's still there, steady, quiet, waiting whenever you need it. If you'd like to keep exploring with me, learning, wondering, resting, you can subscribe, or just return the next time the night feels a little too large. Together we'll keep following the light, one calm thought at a time. Until then, rest well, breathe slowly, and let the universe keep turning without you for a while. You're part of it. Always have been, always will be. Good night.